Good morning and welcome back to day 2 of our Developer Festival. It's a gorgeous morning here at the Shoreline Amphitheater.
Go ahead, guys.
Architecture components world. So over time, their Fragment APIs have kind of evolved, and as of the release of architecture components, a lot of people have been asking us questions like, so how do all these things fit together? So hopefully we'll be able to answer some of those questions today. But first, just a little bit of history. Like, the Fragment APIs go back to 2010 was when they were first initially written, 2011 when they hit a little bit more widespread availability. And really, it kind of comes down to the idea that at the very beginning, everybody just kind of started with the activity when you were writing an Android app. It was kind of your main method with a lifecycle. It's the entry point to your application from the system. The launcher will launch your activity. You get all the on create, on start, resume, et cetera, events that you all know and love. It'll create views for you. It creates the window, gives you a place to inflate your view hierarchy where you do most of your UI work. It binds the view content from your app state, or at least this is where people tended to do it. Keep in mind that this was fairly early on in Android's public lifecycle here. Everybody kind of had this habit of piling everything into one activity because apps were a lot more simple than they are today. And of course, you listen to UI events and update that app state from there as well. So there are so many incoming events, it really kind of became this plumbing exercise to try to break it up yourself. So people ended up with these very monolithic activities. And then something else happened too. Android tablets kind of became a thing. So we kind of thought, how do you make a tablet UI? Well, you take one phone UI, you take another phone UI, and you smack them together, and you have a tablet UI, right? I mean, what could go wrong? So we needed to answer this question of how do I stick two phone UIs together and make sure that it still works on a phone? And fragments were kind of our answer to this question. So as an example here, this approach actually worked pretty well for some applications. Gmail is a great example. So if you take a look here, you have the list of conversations to your current conversation that you're taking a look at. And there's not a whole lot of difference here between the phone version that you drill into versus something that you can show side by side in a two-pane UI. So fragments were really designed to make sure that you could do one thing, and that was to allow splitting up these huge activity classes. This was something that, again, we were seeing the pain that developers were feeling that their activity classes were getting really big and hard to manage. So we wanted to see, could we allow for you to decouple some of the various things that your activity classes are doing to sort of relieve a little bit of that pressure. So that means that anything a fragment can do, or anything an activity can do, a fragment had to be able to do too. And that guided a whole lot of the API design from the beginning. So that meant that you needed to have lifecycle events. That meant that you needed to be able to manage a view hierarchy. It meant that you needed to be able to deal with saved instance state. So packaging everything up into a bundle or parcelables so that if your application got killed in the background, you could restore from that in a clean way. And other things as well, like non-configuration instance object passing. And that's always kind of a mouthful, but I mean, this is kind of the way that you can pass any old object back and forth across a configuration change that doesn't actually kill your process. Backstacks were another really big one, because suddenly, if you were dealing with a single activity where you were navigating between fragments, we wanted to make sure that we preserved that same backstack behavior that you're used to from just calling start activity from screen to screen. So along the way, we asked the question, can we fix some other APIs that were really kind of a pain in the neck in Android to use? On retained non-configuration instance, again, kind of a mouthful. This method kind of had some problems because you only got one object that you could pass from activity instance to activity instance. We didn't give you any easy or standardized way to multiplex different objects together. So for example, if you were composing multiple libraries, we didn't give you a whole lot of help. This was all boilerplate that you had to write yourself. Activity show dialog. Does anybody remember this? A few people, OK.
Please forget it immediately.
Please forget it, yeah. So this was essentially a way to get the activity itself to sort of do something that we knew was missing and kind of a pain in the neck. This allowed you to make the activity on the other side after a configuration change, the new instance of your activity, re-show what is semantically the same dialog. We also had this thing, local activity manager, tab host. Does anybody remember this one? Wow, that is a lot more hands than I thought I would see. So some of you might remember this from, for example, the original Dialer and Contacts app back in kind of the Android 2.0 days. And as you swap between tabs between the normal number pad and your contact list or call log, et cetera, those were actually separate activities showing within a smaller window within an activity. This idea of nesting activities was something that we started offering very early. It had a lot of other issues, though. Activities made a whole lot of promises that Local Activity Manager had a lot of trouble trying to uphold. So we wanted to try and tighten that interface a little bit better for something composable like Fragments that would be able to do the same thing, but with a little bit more expected behavior.
Right, so this whole idea of being able to break up your activity and make it into kind of composable pieces, we have this giant monolith of an activity, and there's other methods of kind of factoring it out into different pieces. But for Fragments, basically the approach was you move that loosely related code, right, those view and all of the state around that view into a separate fragment. And you basically just keep doing this until you've kind of segmented out your activity into something that looks slightly more reasonable, right? You may have a couple of fragments in here that kind of have their own specific requirements and their own specific UI, and your activity just becomes more of a shell for this. But soon after we started getting into this, and when it came up to around Jelly Bean, people were like, but this isn't enough. Like, what if one of my fragments has a view pager in it that also has fragments as each one of its pages? So we get into this, all right, well, now let's break up the fragments into smaller pieces. So, of course, the only way, well, if fragments aren't enough, then you just add more fragments. In this case, child fragments became a thing. So now each one of these fragments could then be broken up into smaller pieces. So this allowed us to again decouple things, and we built a lot of code around trying to make this nested state work really well. To varying levels of degree of success, but it's gotten a lot better over time. So with these things in mind, every one of those fragments, whether it's a small thing just managing a view, or if it's a retained instance fragment, every single one of these fragments give you life cycle hooks. Every single one of them has backstack management associated with them. Every single one of them has a retained object that it can do across configuration changes. And all of them are stored statefully in your fragment manager. That means that the existence of that fragment is actually part of the state of your app. So when your app dies and comes back, that existence in the fragment manager is actually a really important part that, at least from Fragment's perspective, that we're going to do on your behalf. And of course, they all have their own ability to have a view subtree, so that piece of your UI that they manage themselves. And of course, we also allow things like fragments being inflatable and put right into your XML files, and be able to reuse them across multiple layouts. And again, this is also kind of hooking into these same processes. But the biggest issue we found is that all of these fragments do all of these things at once, whether you want them to or not. And most of the time, you're only actually using one or two of these things and not the full 16 things that fragments do that you get as kind of a bundle of deal. So that means that some of these things, like the stateful restoration, means you have a lot of patterns that look like this, where you have to make sure that the fragment manager is in the right state. So in this case, we're actually checking, well, all right, is there no saved instance state, i.e., are we in a fresh run of this activity? And oh, now I need to add my fragment to my layout. So if you've ever gotten this approach where you have one fragment over another one, yeah, this kind of stateful restoration actually being something that was a useful bit, but at the same point, like maybe not exactly what you were expecting or something that you even wanted in some cases. But for fragments, you kind of got all of them together in a package deal. But last year, we kind of took a more holistic approach to how we do APIs. And this really kind of started with a lot of the work we did on architecture components. So all of the architecture components have really tried to focus in on doing one thing well, rather than being kind of the kitchen sink kind of an approach. So for example, lifecycle observers. The ability to have lifecycle and that on-resume, on-start as kind of a piece that is completely independent from other things, something that you can register just if you care about lifecycle. Similarly, for viewModel, we created a new primitive, a new object, specifically for that kind of retained instance state across configuration changes. And of course, this year, just yesterday, we announced a new navigation architecture component, kind of working at the much higher level architecture on how you build your UI and put these things together, and really trying to tackle just the specific problem of how do you move from one screen to the next screen. So all of these things we're kind of really focused on doing one thing well, and we're trying to bring a lot of that to Fragments. But that means that we kind of have a lot of legacy to go along with that.
That's right. So part of this is that Fragments were really designed around this idea of very loose dependencies and loose guarantees about some of the interaction between them. So another kind of quiz for the audience. How many of you know the answer to this question? Does a child Fragments onCreate method run before or after its parent's onCreate method? How many of you are confident that you know the answer? Not a whole lot. How many of you?
No idea? Is that an option?
How many of you thought you knew the answer before I asked the question, and then you started questioning yourself? Yeah, OK. I'll fully admit that sometimes I have to double check this as well, because the answer really kind of depends on whether the parent is an activity or if the parent's a fragment. What version are you running on? Are you talking about android.app.fragments or the support library fragments? Because the answer has been different over time. We've changed this around, and if you were trying to design a fragment that worked across all versions of Android that was writing to the framework fragments, you had to deal with these rules kind of changing out from under you a little bit. You couldn't count on anything. So one of the things that we allowed for here with lifecycle observers is that we really wanted to give a very strict ordering of the callbacks. You have a strict last in, first out callback ordering for all lifecycle observers in any given lifecycle. This is important because it means that you can set up dependencies between lifecycle observers and use lifecycle observers as the implementation details of a particular activity instance or fragment instance, as the case may be. You can make sure to maintain guarantees between certain lifecycle events so that any other lifecycle observers that other libraries you may be using can take advantage of those guarantees that you've configured. Lifecycle observers are created by you. We don't try to recreate them via reflection, which means that you can use any sort of creation pattern that you may find useful within your app. So this seems like a really small thing, but it was a big piece of feedback that we got with Fragments. The implication of that, though, is that you no longer get stateful restoration by the system. Now, again, in some cases, this is exactly what you want. You want to make sure that you have a single control flow path as you're configuring your lifecycle observers. You don't want to be checking, hey, is my instance state going to bring this back for me? I don't want to end up with two of these things, so on and so forth.
Right. So one of these really common patterns that we saw a lot of app developers using is actually a headless fragment, a fragment without a UI that was used basically only to receive on-start, on-stop lifecycle events. So for a lot of these kind of approaches, lifecycle observers are going to give you the same kind of API surface, but with a lot smaller kind of API that you don't actually need all of the things of Fragment. So what does this actually look like? You might have just a simple lifecycle observer that does analytics calls, and your analytics library might want on start, on stop of a particular lifecycle. So the thing here is that this is an independent piece from fragments, from activities. Now that has a couple of super important things in that one, you can test it independently. You don't have to spin up the whole world just to test this piece. You can test it in isolation. Also, because you can create this observer, you can use whatever methods you want. If you want to use a dependency injection kind of model and inject in your dependencies, like that is really easy to do in this model rather than trying to do it in the scope of an activity or fragment or doing that kind of thing. So this gives you a lot more power to kind of split out this into a composable piece. So if you're building a library, you can just use this same lifecycle observer across all of your fragments or all of your activities and not have to duplicate that data or worry about like, okay, well, what state is my instance state in? You can just always say add the observer and we're done. There's no more work you need to do here. So this offers a lot simpler alternative for this specific use case.
All right. We've got some glowing slides to get through. OK. So retained instance fragments were really designed to outlive an activity. These were basically just a setter on a fragment to say, hey, retain my instance state across configuration changes. This was a pretty useful thing because it meant that you could save handles to expensive data or operations. If you start some sort of query that might take a little bit to complete, you don't want to restart that just because somebody rotated the screen or something got resized. It meant that you could reconnect to these same operations after that configuration change. But really, please, don't do UI during this. This was another one of those kind of headache, pain point sorts of things. Fragments do everything all at once. But these were two things that just really did not taste great together. The reasoning for this is, of course, that views hold on to the context that created them. Well, what context do you use to create views most of the time? Well, it ends up being the activity. You don't want to hold on to a reference to an old activity after a configuration change and end up using the same views. Now, technically, it's possible to do this right. You can go ahead and drop all your references in on destroy view, recreate the view after you come around the other side. This was way too difficult to get right all the time, just because references to these views end up leaking out and getting everywhere no matter what you try to do. So this was something that was really just kind of a foot gun waiting to hurt people.
But of course, in the architecture component world, there's a different solution for this retained instance pattern. And that comes in the model of view models. So this was kind of a brand new class. And to be honest, the class doesn't really do a whole lot. It's how it connects to the overall system. So instead of being, again, part of the fragment APIs, this is a more general purpose thing, something that you can attach to any activity or any fragment or any view model store owner if you're building your own framework. And the main thing that's different here, just kind of like the lifecycle observers, is that we are not the owner of creating those objects. So by default, we provide a factory that just creates a new instance or creates a new instance and attaches your application context to it. But at the same point, this is a super powerful hook for, again, kind of adding in those extra dependencies. So if you're using dependency injection, like, again, you have kind of the hooks you need to hook into the view model creation and pass those in just as a constructor parameter. Right? There really doesn't need to be a more complicated structure than that. So, but you get into the same problem of like, OK, well, how do I connect my UI? And the other piece of the puzzle here is a different architecture component called live data. And live data is kind of all about a lifecycle-aware observer. So in this model, in this world, your view model is the one who's storing the data, right? And it's the live data that it has that it can then pass to the activity or fragment as they get created and recreated. And that fragment or activity can just observe the live data that the view model owns. So this model kind of separates things out where instead of it being the view model that needs to hold on to a reference to views, the activity can then pull the information out of the view model. So I think for a lot of use cases where you're using a retained instance state specifically to kind of store this expensive data and do that kind of work, view models offer a really good alternative to retained instance fragments. So what's a super simple one look like? Well, in this case, we're going to use an Android view model So here we get a reference to your application context. So this is really useful if you're doing things like a service locator kind of pattern. But the important thing here is that the view model stores an instance of a live data. In this case, a live data that has a list of our fancily named expensive data class. Now, normally you'd put this in line, but slides are hard. So here we're using it in it, and we're getting our data from a room database, a simple ORM database. But you can really get this data from anywhere or set up kind of the correct lifecycle events here so that your live data can kind of get into the right state. But that means that your actual fragments or activities don't need to know where this data came from. Right? It's encapsulated in the view model. And again, we're in this same thing where we can now test this view model in isolation. We don't need to create activities. We don't need to create fragments to get to this same view model. We can just use them in isolation and make sure that all of the work we need here to get our expensive data and make sure that it's in the right state can all be done kind of separate from the actual UI pieces of the framework.
All right. So everybody's favorite topic when it comes to the Fragment API is fragment transactions, because this is a statement that's said by pretty much no one ever. Fragment transactions are asynchronous by default. If you call commit on a fragment transaction, then that ends up getting posted for later, and it'll occur kind of on the next normal handler pulse of your main thread. Or if another lifecycle event is coming up, we'll go ahead and execute all the pending transactions, bring it to a consistent state before we move to that next state. Now, this actually has a few benefits to it, believe it or not, for as much as everybody gets kind of frustrated about it. And the biggest one is that you don't have any reentrant fragment operations. This means that if you end up manipulating fragments within, say, the onCreate of another fragment, then you don't start getting into a state where you have a half-initialized fragment while you're waiting to bring another fragment up to speed. Now, this is a source of countless bugs. I think that it was even just earlier this week, last week, that we were helping a developer troubleshoot some other reentrant behavior bugs that was coming from view callbacks, for example. And this is the sort of thing that can be really, really subtle. And the asynchronous fragment transactions sidestep all of it. And that was kind of convenient. The drawbacks are, of course, that the observed state at any given point in time doesn't actually reflect any of the queued transactions. So this is a huge problem. This basically means that if one piece of your code submits a fragment transaction, another piece of your code tries to read something out of state that that fragment would have set up for you, whether that's another view hierarchy that would have gotten attached to sort of a sub-hierarchy to your UI, or whether that's just some data about a pending operation, say for one of these retained instance fragments. This essentially means that you can't trust anything about the current state of the app. It means that you can have various data races just within the normal main thread handler of your application. We've even seen people run into the issues of sort of the layered fragments on top of one another because of this issue, because they were checking the fragment manager to see, hey, what is my current UI pane, for example, that's currently there. It said, oh, look, nothing. I don't have anything to do. Let me go ahead and make a new fragment transaction and stick something there. But there was already something in flight. So this was something that was really kind of a pain in the neck, and everybody loved when the Commit Now API was added because it lets you do something right immediately as long as you promised that you weren't going to do anything with your current fragment manager as part of that transaction.
But we kind of get to this point where, OK, now we have all these fragment transaction code in your app, and very subtle changes that you may not pick up in a simple CL all of a sudden are changing the whole behavior of your app. And we really took a look at this and we said, well, like, should you really have to be writing all of these fragment transactions by hand? Like, for so many of the use cases, we can do a little bit better here. We can do a lot better here, especially for the really common cases. So we built navigation. Brand new architecture component that's really kind of focused on that screen-to-screen transitions between fragments or other UI pieces. Because we really wanted to make it work well with fragments. Fragments are a really great way of getting access to lifecycle observers and view models, and also being an owner of a view. And those are really kind of the main pieces you need when you're trying to build a good Android app. At the same point, we realize there's a lot of things that fragments do that we don't really want you to have to deal with yourself. So one of the things with navigation that we really focused on was actually being able to take ownership of the backstack. Make sure that the navigation component can actually handle that backstack for you. Whether you're using fragments or you're using something else, the ownership of that backstack kind of lays with navigation. And that gives us a lot more flexibility and a lot more ability to be a little bit more prescriptive and a little bit more opinionated on what is a good thing to do and what's a not so great thing to do, and kind of give you a lot of the same power of fragment transactions without actually having to touch one with your bare hands. Because again, we're trying to make things so that you have all of the power without necessarily the headache and the problems that run across some of the things that Adam pointed out. So we're going to be talking in detail about navigation tomorrow morning at 8:30. I know you're all early risers, but I wanted to give you a little bit of a preview of kind of how simple this could be. So we actually offer a helper method where if you want to click a button and do a full screen transition to another fragment, we have a create navigate on click listener that literally does just that. All you need to do is pass in the ID of one of those destinations that you've set up in navigation. Now, this looks a little bit magical. So what is this actually doing under the covers? Well, really what it's doing is it's using this nav controller object. And one of the things that I find super useful about navigation is you can actually find that nav controller from any view or any fragment that's been created by navigation. So here we're using a Kotlin extension, which makes this a lot easier. If you're in the Java land, it's just a static method. But here we can find from any view, we can just say find nav controller and get an instance of our nav controller, and then just call navigate. And this navigate call knows how to do fragment transactions. So our nav controller in this case is set up with a fragment navigator, our own class that knows all about the correct behavior of doing fragment transactions and how to do all of that work for you, so that from your code's perspective, you can just call navigate and we'll do the right thing for you. So obviously there's a lot more here, like if you want to pass arguments, like you can do a bundle approach. We also have a lot more things around that specific case that we'll be talking about tomorrow as well as setting things like separate animations and other objects in here. So you have a lot of the same power, but you can also make it really easy to use and move a lot of the code that used to be a fragment transaction that you'd have to make really sure that you got right into something that navigation can understand and help with. So Adam, we've talked a lot of things about why not fragments, but this is kind of a fragment talk, right? So why?
I think that's why everyone's here.
Yeah, so why fragments? It's 2018.
It is 2018. So what are fragments still good for after we've sort of carved off some of these other extension points? So before we talk about that, I think it's kind of important to go into a little bit about the package layering involved in the Android framework, specifically Android.widget versus Android.app. Now, Android.widget is really kind of designed to hold all the mechanism for your UI. That means that this is all the stuff that shows state to the user and things that reports user interaction events back to other higher level portions of your app. And really, that's it. Anything that's in the widget package is really meant to only do these two things. Whereas Android.app, which is where fragments live, activities live, so on and so forth, that's where your policy goes. This is what defines what state to bind to widgets. This is what defines how you should respond to those user interaction events and how to issue changes to your data model. Anything kind of at that layer or above, no matter how you may factor it, this is kind of how it breaks down. So this also brings us to this idea of inflatable components, which is something that comes up quite a bit. Since you can inflate a fragment from a layout, people found out really quickly that you can use a fragment to compose some of your views together and create basically like a custom view, but with a fragment. And really, some of this kind of comes in because people start asking, just if this view had a life cycle, I could something. But really, you kind of want to use that as a stopping point and just kind of ask yourself, like, what is it about this particular view, remember, mechanism only, that needs a life cycle? Views should really only be showing data that they're given or publishing user interaction events if the user clicks, touches, or performs any other action on the views themselves. None of these things need lifecycle events to accomplish that goal. So you should really kind of watch out and figure out, OK, do you need some sort of policy layer that sits above that? This is where fragments are really useful, because you can compose them of higher level controls. It means that they can be self-sufficient. They have their own life cycle. They know how to hook into some of these things. It means that inflated attributes can actually become fragment arguments. So you can make these things super self-sufficient and implement cross-cutting UI policies that you don't have to worry about in terms of like the overarching top-level parent context. This ends up being really useful for things like, even just something as simple as ads, something where you really do need to control for a life cycle about when a user comes and goes, perform a request out to the network to fetch the content that you're going to show. But really, you don't want that code getting all over throughout the rest of your application logic. You can use this for other sorts of like independent info cards, things that are, again, fully self-contained. And the parent doesn't actually need to be involved in any of the data routing from your central repository or whatever other sort of model you're using under the hood in order to get that on screen and get the user interacting with it. So one example of using the fragment arguments for this is on screen here. This is the sort of thing that could probably benefit from some extensions or helpers, but overall, it's not too bad. If you define a stylable to go ahead and inflate some of those arguments, just assign the values to the bundle, set it there, and then you can route all of this logic through your normal fragment argument handling that appears throughout the rest of your fragment implementation.
So one of the other use cases that we found really useful for using fragments is this kind of app screen kind of model. So where a fragment is taking the vast majority of the screen. It's really the main content of your app. And this is really kind of where navigation comes in and really kind of takes away a lot of the rough edges of fragments. So you're just left with the architecture component hooks and a view. So in this model, it's a lot easier to move towards a single activity app. If you've listened to Chet yesterday, this is kind of our recommendation going forward, to kind of use activities just as an entry point into your app. And then your content, the actual things that the UI, the pieces that developers or users actually work with, are the fragments of your app, right? The actual content is in fragments. So with this model, the only thing the activity needs to do is handle kind of common app Chrome. So if you're using an action bar still, or if you're using like bottom nav or a side nav, these would be good things that the activity can manage. But the rest of it can be decoupled destinations, decoupled screens. All of these fragments can be much more independent from one another rather than being tightly coupled together. So this allows us to kind of move a lot of the things that normally you'd have to deal with manually into a system that we can help you out a lot more on. So for navigation, for example, we're going to give you the hooks that you need to set up the transitions and animations needed to transition between these screens. And it's something that can be done in navigation rather than something you have to do by hand. Of course, like, these aren't mutually exclusive, right? You can still add a fragment to your layout or have nested fragments underneath these things. So it's not an all or nothing kind of an approach. It's just one method that, yes, this larger kind of content-based fragment is still a really good way of kind of bridging the gap between the Android.app world and the widget world. Another use case that is still super useful is around dialog fragment. Again, we talked about kind of the activity show dialog. I hope everyone forgot that by now, like I said. But dialog fragment is really kind of the same approach, where instead of it being something that you need to manage and make sure is visible or not visible, it really kind of helps encapsulate the interaction between a floating UI. Like if you have a really important question to ask the user, a dialog is probably a useful case in some manner. But it's also something that we've started to see a lot more. In Android P, for instance, the biometric prompt for fingerprint is now something that is in a dialog kind of model. So this is actually something that we found really useful. And part of it is that we can leverage some of that instant state restoration that you get for free as part of Fragments with your dialog. This means that you've asked a really important question. Otherwise, why would you show a dialog and interrupt the user? But you really don't want that to disappear when you resize your screen on a Pixelbook or rotate your device on your phone. It's a really important question. We want to make sure that we do some of this instant state restoration for you. At the same point, like, dialogs aren't just a floating UI, right? There's also bottom sheets and bottom sheet dialog fragment, specifically built around kind of having different kinds of floating UIs that live above your main content, without necessarily being just the like dimmed background kind of traditional dialog of yore. So we're really trying to get to this point where, yes, using a dialog fragment is great if you have this UI that you really don't want to lose, right? It's really important for the user. You know, obviously for things that the user could lose, it's probably not a dialog that you want to use. It's probably a snack bar or another approach here. This is my favorite part about dialog fragment. There's literally nothing more you need to do. You call show or show now for the synchronous method, and that's it. It's very much kind of this model where we're going to do the fragment transactions for you. Again, like, we don't want to be in a model where you have to do a lot of complicated work yourself. For a dialog fragment, you can literally just call show, and it'll do the right thing, and it'll get you back into the right state.
All right. So one of the other things that people tend to use Fragments for quite a bit is managing options menus, and specifically merging some menus into some common, into a common toolbar or into an action bar that's global to your activity. So Fragments support options menus because activities support options menus. This kind of calls back to that initial design goal where Fragments had to be able to do anything that an activity could do. And the most common use case in this today is for calling set support action bar for your toolbar, which then sort of binds whatever your current context is to a particular toolbar within your UI. Now, this is really great if you have some fixed common Chrome. So in the navigation world, if your toolbar never changes between screens, then this is really handy because this means that you can populate that with whatever actions are relevant for what's in your main content. Fragment pager adapter is another really great one that people use this for quite a bit. If the actions change across pages, then all of this is just kind of handled for you. The system takes care of it. Now, the alternative to this is that you can go ahead and directly manage the menus as toolbar view data. So most of the time today, your UIs are such that the toolbar or other sort of menu management is really kind of part of the content. I mean, this was something that you saw back in a lot of Holo UIs where the action bar was always fixed common Chrome. But now you have these collapsing app bar layouts and things that are much more sophisticated to the point where doing this sort of global wire up is almost jumping through hoops that you don't really need. So don't make it more complicated than it needs to be. If you don't have common Chrome for this, then directly managing some of the toolbar's menus as view data is as simple as this. Like, it's a couple lines of code. There's not a whole lot to it. You inflate your menu, you attach a click listener, and you can keep all of this a little bit more self-contained rather than having this leak out into the whole activity options menu at that point. So one of the other things that we get asked a lot is about testing fragments. Testing fragments is a whole lot easier than testing activities. You don't have to spin up the entirety of the world, an entire new activity with sort of the back and forth in an instrumentation test to the activity manager to make this work. The nice part about this is that from quite a few years ago, we've had this class fragment controller that is able to drive the life cycle. So you can go ahead and you can create just a test fragment manager, test fragment controller that can test those larger fragment components in isolation away from everything else that might be happening in the activity manager. We use this pretty extensively for the existing support library tests ourselves. Now, we make this possible, but truth be told, this is really not the best interface for doing it. It ends up looking a little bit like this. Or you could go through some of the support library tests in AOSP and see kind of the example of some of the utility methods that we've set up for this. We should really probably wrap this in some better move to state type of method. This is one of those cases where we've fallen into a trap ourselves of something's possible, it's maybe not great, the rest is kind of left as an exercise to the reader, and we kind of just need to do better on this part.
Yeah, so one of the other pieces that kind of came alongside of fragments, more from a convenience method than anything else, were loaders, a kind of precursor to a lot of what we've done in architecture components on doing retained instance states. And one of the things we've done recently is actually tried to decouple them from fragments. So how do we actually do this? Well, instead of being their own special thing, we actually rebuilt them on a lot of the architecture components, right? Using these new primitives that we have of live data and view model to kind of make these a totally independent thing. So now you can actually use loaders in any lifecycle owner, view model store owner class. So activity, fragment, if you're building your own kind of thing, it works equally well in all of those cases. So what does this mean? Well, it really just means that you have the same loader you always do, but instead of calling get support fragment or loader manager, you can just call get instance. And we'll do all the hookup for you. We know that you're in a lifecycle observer, so we know how to hook all that stuff up for you. And we really were able to kind of cut out a lot of the stuff, cut out a lot of the custom behavior here, so that we can kind of rely on these new things to give you stronger guarantees around lifecycle. So we've talked a lot about fragments, and we've talked a lot about fragments in the past, and we've talked about fragments in 2018, but there's another question. Where are we going with fragments? What do we still have to do? So some of this is just coming down to building in those stronger guarantees, trying to separate the desired behavior, things that we specifically set out to put in, versus incidental behavior, more behavior that has just been around for 6 years and is not necessarily something that is a codified standard. So we're trying to move towards more of a model where you can be very confident in exactly what's going to happen when you're using fragments. Another case is trying to do the same thing that we did with Loader Manager in re-implementing some of these existing APIs on top of these new primitives. For example, like being able to rewrite a lot of the internals of fragments, so they're actually using lifecycle observers under the covers, right? So these kind of things allow us to kind of make sure that all of our components are on the same page and really doing the same thing. So a few other things. Again, trying to move towards a world where we have the correct set of signals and activity callbacks so that any interested component can be it. That means that fragments are not a special snowflake anymore. They're just another component, another tool in your toolbox, using the same composable hooks that you'd always have. So really trying to play well with other components so that it's not an either or, it's a both. That we can work together, that you can use fragments alongside other components, and it just works.
All right. So options menus are, of course, one other thing that we still don't have a great answer for this in terms of how we want to decouple this. I mean, in a lot of ways, I would like for options menus just kind of as a concept to be deprecated. But for right now, we still need to make sure that we meet all those same use cases for when you do have Common Chrome or for when you're paging through some different content.
30 seconds.
Next one? Maybe? There we go. Okay, so Android.app.fragment manager, some of you have noticed, is now officially deprecated. So no more of this kind of behavior changing out from under you, having to design against different variants of it. This works a whole lot better in the Android X packages and support library before it, because this means that you no longer have to worry about all the bugs that were fixed over time. It allows us to make larger changes to the behavior and API. Please send us your wish list for the things that you'd like to see us do for some of this too. We are going to be over in the sandbox area right after this, so please come say hello. Tell us what you'd like to see next. And thank you very much for coming.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside. Thank you.
Good morning and welcome back to day 2 of our Developer Festival. It's a gorgeous morning here at the Shoreline Amphitheater, the backyard of our Google Mountain View campus. During each of the session breaks will be our conversations with special guests like the visionary production designer for Black Panther and the astronomer who is using AI to uncover the origins of our solar system. We'll also take you to the sandbox for some playtime. And when we're not in the sandbox, we'll be taking you around the festival to enjoy everything that's happening here at Shoreline. During the first session break, I'll be speaking with Jeff Dean, head of AI at Google.
Good morning, and welcome to the second day of Google I/O. Thank you all who made it here bright and early, and a big warm hello to folks on the live stream. This session is about Android Things, the version of Android that was specifically designed for IoT products and embedded devices. My name is Vince, and I lead product management for Android Things. Yesterday, you've heard about the incredible momentum on Android. Over the years, we've extended Android into many different types of devices beyond phones and tablets, wearables, TVs, auto, and last year, we announced a new version of Android called Android Things, specifically designed for embedded devices and IoT products. I know many of you have been tracking our regular developer previews and are already building great things. I love reading about the projects. It's so awesome. For some of you, this is entirely new. You're just getting started and want to know what Android Things can do for you. So let me just get started with some of the obvious questions. What is Android Things for? What problems does it solve? People have been making connected devices for many years. What's different now is the profound revolution in machine learning. Powerful models and tools are available to all developers, and there's ever-increasing demand for smarter devices. Traditionally, your only option when building smarter devices was to delegate some of the serious processing to the cloud. Now, it's possible to run much of it on device, which is useful if you need low latency, or if you're handling sensitive content, and so on. And this growing area is exactly where Android Things is targeted. It is for devices that need powerful, on-device intelligence. When we look around the devices that populate our homes and businesses, IoT is, of course, very broad and diverse. So in a sense, the product categories are all familiar. We all know these. It's just the user expectations that have gone up, way up. Let me just pick on two use cases. At home, we increasingly expect to be able to talk to our devices, and they'll know who we are. Another one is smart building devices, such as cameras, that can now detect how many people are in a room and do something useful with that. For example, talk to the HVAC system. We know users want these kinds of devices, and we know we could build them. But of course, building these devices is actually very hard, especially maintaining them over time. It's actually very expensive to do this. We know this at Google because we've been shipping these kinds of products. Well, what's so hard? Well, first off, we're talking about an entire device, so a whole physical product. So we're responsible for the entire software stack from the bottom all the way up to the product experience. Now, of course, the product experience is where you'd ideally be wanting to spend most of your time, because that's where users are interacting with. Below the product experience, IoT devices are currently built using many different flavors of roll your own Linux or Android. Every device is different. So it's hard to expect consistent and reliable APIs. When you go from project to project, you want to reuse what you've built. You want to get support from a large community. At the same time, we're talking about richer experiences with these devices. So obviously, you need to get your app working. Chances are you need to get third-party apps and services working. Each time, you need to figure out basic building blocks, like a reliable setup flow from a smartphone, for instance. You could do it all yourself, but it just feels like extra time and effort. Second, you need to get down to the hardware. Building prototypes with microprocessor SoCs have certainly gotten easier over time. People use all sorts of prototyping tools to get that done. But those don't get you through to production, let alone commercial launch. We're talking about PCB design and layout involving high-speed, highly integrated components, SoC vendor relationships for general support and bring-up, component supply chain, access to parts in low volume, and so on. These are all very different skill sets you need to hire for your team. Again, prototyping solutions get you off the ground, but that's it. Finally, while it's amazing how much these devices can do on our behalf these days, the flip side, of course, is that they have the keys to our homes, our businesses, our back-end systems. Clearly, there's more and more to gain from attacking IoT devices. Perhaps less obvious is why it's hard to provide the security. Well, it turns out it's incredibly expensive to harden products out of the gate and to keep them updated over time. It involves a lot of back-end infrastructure to do this. We know this at Google because we've been doing this for many products. Meanwhile, there's immense cost pressure from end consumers, of course, and it's hard to amortize costs without large volume. So, those are the issues that our engineering teams and our business teams focused on when we built Android Things. The thinking was, we could take care of all the challenges that make development expensive. We provide Android Things free of charge. You have less to worry about. Our goal is to reduce the barrier to building powerful, intelligent edge devices and make it more accessible to everyone. Now let's take a look deeper. About building on reliable and consistent APIs, Android Things is Android. As you'd expect, you can rely on the same Android APIs and Google services as when you build for phones. Familiar tools such as Android Studio and the Android SDK are available. You can build on Google Play Services, Google Cloud Platform, Firebase, including the most recently announced ML Kit that you heard about yesterday, and more. Of course, you're building hardware. So it's also about component providers, SoC vendors, and so on. As a device maker, usually you'd be spending a lot of your time interacting directly to get to a working image. With Android Things, we've already done the hard work for you. That means you have access to hardware reference designs. It means the build support package comes from Google, and you get a working image right away. You can scale to production because we've signed agreements with the SoC vendors to guarantee support over the long term. Literally, our goal is, if you know how to build an Android app, you can now prototype IoT products and take them all the way to production. You don't have to be a hardware engineer or firmware engineer to do this. Finally, on security, our strategy is to have security features built into the platform. OS hardening is on by default, and you don't have to spend time figuring it out yourself. What about fixes over time? Regular security patches come regularly from Google. Google provides all the backend infrastructure for you to be in control, and you can decide when those go out. Now, let's go a bit deeper. How do all the pieces that I just talked about fit together? Developers often ask me, how is Android Things different from Android? How is it different from AOSP? I found that the best way to describe Android Things is that it's a fully managed solution beyond the AOSP model. At the lowest level, we define turnkey hardware in partnership with the silicon providers. This is in the form of a system-on-module architecture. I'll talk more about that in a bit. But the way the model works, though, is that we work closely with the SoCs to land code in the Google tree. Google is the one hosting the BSPs. In fact, we have the system on modules in our test labs hooked up for continuous integration. Moving up to Android in the framework layers, Android Things is Android. What we've done is we took Android and we shrunk it down to around 50% of the footprint of AOSP, meaning it can run with lower compute and storage requirements. Security features are built in, meaning they're done for you and they're on by default. Up at the top is the app layer. We formalized the boundary so all of the product-specific code lives there. We make sure the Google services you might want to work with work well out of the box. So your apps can rely on Google Play Services, Firebase, Cloud Platform, Assistant, and more. Finally, what's pictured on the left side is the management console. It's shown cutting across everything from bottom to top because it's where you control what exactly goes into your devices. It's where you get access to the BSP that Google and the SoC vendors are supporting. It's where you create full product builds with all of your apps and services included. It's where you manage releases and update channels over time. As you can see, that's why I've described Android Things as a fully managed solution. It gives you a portfolio of reference hardware to choose from. It gives you Android with security and key services working on top. It gives you a console to configure what exactly goes into your devices. It's all of the ingredients necessary to prototype and scale to production. On behalf of the entire Android Things team, I'm super excited to share that we are now generally available. Version 1.0 is the first long-term supported release. It came out just 2 days ago on Monday, fresh off the press. Many of you have helped us along the way. We've seen more than 100,000 downloads of our Android Things SDK. We've received feedback from more than 10,000 developers. This was all critical to get us to this point. Thank you so much. Now, what does version 1.0 mean for you? Most importantly, it means Android Things is a stable base for you to build commercial products. In fact, we've worked with a few partners to put Android Things through its paces and vet whether we could power real shipping products. Let me show you a few. What you see here is our first shipping product, and it really put our program to the test. This is a smart speaker by LG, and it landed on shelves last month. So the story is, LG wanted to build a smart speaker with high-end audio and go to market quickly, and they felt we'd be a good fit. One of the first things was to determine a good hardware reference design. The system on module architecture that we talked about before is in all the shipping products. From your point of view, this is all done, so you can just pick it up. It will be an officially supported platform, and you're good to go. Well, LG was also concerned about ongoing security fixes and the infrastructure to send over-the-air updates. Bottom line is that these guys want to be working on amazing audio, not worrying about staffing up a team to do security and do OS bring up. This is a smart speaker, so there's non-trivial audio processing for audio casting and the Google Assistant. We make sure these work well, and they're part of the full solution as well. There's more OEMs working on smart speakers, and they'll be coming out in retail soon. Soon after, partners chose us for a new product category called Smart Displays. The idea is a visual Google Assistant. There's deep integration with photos, maps, video calling, YouTube, and so on. What you see here are devices from Lenovo, JBL, and LG. All these guys wanted to move quickly, and they felt that we could help them do that. At the time, we were already working with SoC vendors on expanding our portfolio, and we locked in on a common system on module for all these products. In other words, if you look under the hood, all of them are using the same system on module, which is quite cool. Again, when you work on your project, you can just skip all of that upfront SoC work and just pick up the supported design. The OEMs were also concerned about ongoing updates, especially because this is a new product category. They're expecting frequent updates, and during development, they wanted to partition folks into different groups and A/B test the user experience. This is where our console was put to the test to manage all the builds, release channels, and frequent updates. Now, of course, IoT is broad and diverse. What's the most exciting for me is seeing what everyone has been building based on our developer previews. Here are two examples. The product on the right is made by a company called Byteflies, a wearable health startup based in Belgium. The hand is holding a sensor that measures vital signs, and the docking station sends data back to the cloud. Byteflies let us know that Android Things help turn their docking station into a secure hub. They don't have to worry about ongoing security fixes and how to update the device. The product on the left is made by a company called Morigo, based in Montreal. They built a network of large photo displays running Android Things, and they're connected to public photo booths in downtown Montreal, which sounds really fun. Morigo wanted a solution that could help them move quickly, and Android could help them do that. If you're building a new product powered by Android Things, we want to work with you too. We introduced a special limited program to partner with the Android Things team for technical guidance and support. If your company is interested in learning more, please let us know at the link. So now that I've shown you some real products, let's switch gears and go back to how all the pieces fit together, starting from the bottom. We talked about the hardware reference designs. We talked about the system on modules. You might be wondering, what do they actually look like? So on the right here is a system on module, SOM for short. This one is based on an NXP IMX7D. All the high-speed and complicated-to-design electronics are in the SOM. The key components such as the SoC, memory, flash, Wi-Fi, Bluetooth. The baseboard is what you see on the left. This one shown here is actually one of our development baseboards. But you can imagine designing product-specific baseboards with just the right set of connectors and plugging the SOM on top. The SOM is complicated and quite costly to design if you were to do it yourself, and we've done the hard work for you. It would also be very expensive at low volume, but the SOMs are what everyone will be using, and that helps drive up volume for everyone. The baseboards are much less expensive to produce, even at lower quantities. The electronics are much lower speed and less dense. What I've shown here is also referred to as a physical SOM because the SOM is on its own board. You could also imagine designing it in so it's all on one single board, and we call that a virtual SOM. This would allow you to save on cost at high volume or to better match XY dimensions for your product. Going back to the 3 smart displays I showed earlier, they all use different tactics. Some use physical SOMs, and some design it in virtually. For each SOM, Google hosts the board support package, BSP for short. In other words, you don't have to interact with the SoC vendors. There's a stable layer of separation with the BSP that makes your code portable. You could imagine starting development on one SOM, then swapping over to another at later stages of production if your design changes, without having to change your code. Now, part of making the SOM architecture viable is guaranteed support. Behind the scenes, we've been working really hard with the SoC vendors to work out the collaboration so you don't have to talk directly to them. We are announcing SOMs that are certified for production. The list includes hardware from MediaTek, NXP, and Qualcomm. More specifically, SOMs on this list have guaranteed long-term support and all security features built in, making it possible to bring prototypes and go all the way to production. Hardware and reference designs for these SOMs will be available in the coming months, so stay tuned. SOMs supported for development is already available now. They include hardware from Raspberry Pi and NXP. Development hardware have a large community of support and are readily available in retail even at unit quantities, usually for cheap, so that gets everyone started right away. The beauty of the Android Things model is that you can easily swap over to SOMs certified for production once you're ready. So everyone has been wondering, for the list of SOMs that are certified for production, the ones on the left, how long is the support? How much does it cost? Each SOM certified for production is supported by Google for a minimum of 3 years from the time it was first made available. What this means is you will get regular security patches and stability fixes from Google for you to push to your devices. You can even set your devices to auto-update and not worry about it. In other words, you get to fully harness the power of the Android security team. Of course, you can push your own updates to your devices anytime you want for the entire product lifetime. Well, what about fees? There are no charges to using Android Things. There are no license fees for the OS or the management console. The API surface is stable, meaning the length of support is provided for each major version. This is why we refer to 1.0 as long-term support. We know moving to a new major version can be disruptive, and it may not make sense for many IoT products, so there's no need to do that. Let me show you in a bit more detail. Each line on this chart represents a major version of Android Things, and of course, 2.0, 3.0 are in the future. As I said, every major version will have long-term support, the minimum 3 years we talked about. These major versions do map to underlying Android desserts and will pick the right points to intersect over time. The important point is, when 2.0 comes out, 1.0 and 2.0 are supported in parallel. The security patches and stability fixes come regularly, and that's what each white dot in the lines represent. We'll also have minor feature updates on the latest major version. This is so we continue to address community feedback in a timely manner. So we won't wait for the next major version to push these out. In fact, in the coming months, 1.1 will come out with improvements for you. One last note on SOMs. Obviously, the work we do behind the scenes with the SoC vendors is never ending. It's an ongoing process. We'll continue to expand the SOM portfolio. You saw the vendors that already have something listed officially, and we're deeply engaged with others too, like Rockchip. The point is, once we put a SOM up as certified for production, it's a commitment. The ones you saw all support 1.0, and when we eventually add 2.0, we'll be explicit about which SOMs support it. Now, we've been talking about the next layer up already, since Google hosts the board support package for every SOM. But what does it actually look like? Let's go into that in a little bit more detail. What you see here is a simplified software stack for a traditional Android mobile device. Going from bottom to top, the kernel up to the HAL layers is primarily focused on enabling hardware support. The Android framework provides a rich set of APIs and services for apps. And the applications on top provide user-facing features, right? Now, in IoT devices, you can imagine many of the included components not making sense. Well, you know, embedded devices are usually single-purpose. They may not have a screen. Users are not installing apps, and so on. So, first, Android Things removed most of the user-facing applications and visual framework components that don't make sense. For example, there's no reason for a text messaging app. This removed unnecessary complexity and reduced the footprint of the distribution. If you build a device with a display, you have full control. There's no system UI to get in the way. Now, with or without a display, the UI toolkit portions of the framework remain available to your apps. Activities are still the primary component of an Android app. The framework delivers all input events to the foreground activity, which has focus. Next, we formalize the boundary between the system and the product-specific code necessary for the device. All the product-specific code is above the line in the app layer. Everything below the line is provided by Google and our SoC partners. This way, you don't have to figure out how to put together a working image. Google can sign the full image and guarantee automatic security updates over the support time frame. You might be wondering how this boundary can work in practice. Well, one crucial piece is the Android Things support library. I'll touch upon the API surface briefly. For example, you may be wondering how to control hardware. The Peripheral I/O API allows apps to interface directly with low-level peripherals using industry-standard protocols like I2C and GPIO. User space drivers allows apps to inject hardware events into the Android framework. You might be wondering how to call APIs that usually involve a dialog or a view to the user. These don't make sense when displays are optional. So we've added APIs to control settings, control device updates, and configure local area connectivity, including Bluetooth and LoWPAN. Now, I'd like to show you the complete picture. We've already talked about the portfolio of SOMs you can select from, and these come in at the bottom. There's actually two more building blocks. The first is device configuration, and the second is security. Let's start with device configuration. It's the other crucial piece, along with the Android Things support library, that helps maintain the formal boundary that we just talked about. You see, SOMs can support a wide variety of hardware, so in many cases, the OS needs to know which hardware is actually connected in order to properly configure those interfaces. For instance, which audio devices are connected where, and their formats, pin muxing. We provide a configuration system so OEMs can define their connected hardware in the console, which will customize the image correspondingly at build time. Cool. Let's talk a little bit about security. Well, first off, the OS hardening that we do on Android is enabled for Android Things. So these are things like permissions, the application sandbox, mandatory access control with SE Linux, kernel syscall filtering, and so on. Images are signed. You don't need to run any signing infrastructure yourself. Google provides the infrastructure to build the full image for you. Disk partitions are signed for security. Verified boot, which is fully implemented for SOMs certified for production, make sure you're running a valid image at all times. Now, there's lots of interesting scenarios that are handled for you, and I always get a kick out of thinking about them. For example, what about running an older image with a vulnerability that has since been fixed? Rollback protection makes sure this doesn't happen. Another one is per product keys. So images only run where intended. You can ensure only your product images run on your devices. Finally, you don't need to run any update infrastructure. Google takes care of building and serving all updates, the same infrastructure we use for our own products. All right, now we're moving on to the app layer, where all of the product-specific code lives. What does building an app on Android Things look like? To get started, we want access to the Android Things support library we just talked about. It is built into the supported devices as a shared library. We're showing code snippets from 2 files here. At the top is a snippet of the build Gradle file. You declare the SDK dependency there, and it'll get pulled in. The bottom part is a snippet of the Android manifest file. You notice we use the uses library tag so our app can access the device's shared library. Below that is applying the home category to one of your activities. What this does is that the system will launch this activity automatically on boot and relaunch it if the app terminates. This is, of course, exactly the behavior you'd expect for embedded devices. Now that we have this set up, let's do something useful. The example here is very simple. It detects a button press, but it's a good demonstration of how to interface directly with peripherals using the Peripheral I/O API. The code snippet at the top is the Android manifest file. This is where we declare the required permissions to use Peripheral I/O. The code snippet below is the activity. There we use the Peripheral I/O API to open a connection to a GPIO pin, which is where the button is connected. We configure the GPIO pin as an input and attach a callback. And that's pretty much it. Good to go. A similar workflow is used for all of the Peripheral I/O interfaces. So you can imagine adding a few lines, and you can light up an LED. Of course, it's not just about simple stuff. There's a wide variety of peripherals out there. Your app can interact with all kinds of sensors, actuators, and so on this way. We've expanded our community hub this week as part of the 1.0 announcement. The site is androidthings.withgoogle.com. It brings together all of the information in one place: samples, documents, forum. Also, as you'd probably guess, much of the code we showed before about driving hardware peripherals isn't exactly product-specific. You can get up and running quickly with pre-built drivers from our peripheral driver library. These drivers abstract the low-level communication details associated with many common hardware peripherals. You can browse the driver library at the Community Hub, and we're also now accepting community contributions as well. So let's all make this better together. Be sure to check it out. Well, where do you go from here? Well, you have full access to the Android SDK and NDK when building apps. You can use Android Studio, develop your apps in Kotlin. You can leverage standard developer tools and third-party libraries. Many projects find Google Play Services, Firebase, Google Cloud Platform, etc., very useful. In fact, you can create an end-to-end demo very quickly. For instance, if you're collecting sensor data, you can use Cloud IoT Core to help you ingest data and do something with it in the cloud. If you're taking photos, the Cloud Vision API, for example, can help you with object detection. Of course, there's a lot more. We'll have many samples in the community site for you to check out. Let's say a bit more about Google Play Services, because we've created an optimized, lighter weight version of that for Android Things. It's optional, so it doesn't take up space if you don't need it. Many developers do find it very useful, though. You can literally tick a checkbox and add it to your build from the console. You can find the Firebase APIs in there, which we use in many of our samples. For example, the real-time database is very useful when you sync device data. You can also use the new ML Kit to integrate Google's machine learning technology into your app. There's, of course, a lot more in-play services, Fuse location APIs, nearby for setup, maps, and more. The final piece to Android Things is a console for managing what's running on your devices. It's shown vertically, cutting across everything from bottom to top, because that's where you manage all the builds and releases for your entire device fleet at every stage of the product development process. Let me explain. Here's a very simplified view of the product development flow. Every product goes through the prototyping phase where you just want to get something working, then a series of hardware validation manufacturing stages, and finally, commercial launch. At the beginning, you may pick up one of the development SOMs because that's the easiest thing to do, and then later swap to one of the SOMs certified for production. After you get the hardware, you might be wondering, well, how do I assemble an image and push it to the device? In the prototyping phase, you probably just want quick access to a generic image and to get you going. You might only care about one device. So you go to the console and tell it which SOM you've chosen, and that's pretty much it. You can then flash the supported image and siloed apps to your device. As your product evolves, you'll come back to the console to customize a lot more. For instance, you may want to change the partition sizes. You may want to include Google Play services because your apps need it. You may want to modify the device configurations at build time based on the peripherals that you're connecting. You may start caring about a lot more devices. For the smart displays and the smart speaker devices that we showed earlier, the OEMs use the console to split devices into groups. So developers, QA, early beta testers, they're all in different groups. They all have different builds and on different update channels. All of this is configured from the console. When you go to production, you obviously need to assemble the, sorry, previous slide. When you go to production, you obviously need to assemble the entire factory image that includes your apps and services. You want to update your app over the lifetime of the device. It's important to have control over rollout. For example, rollback if something goes wrong. Gradual percentage rollout so that you can go slow and check that things are going well. Access to metrics so you can see that things are going in the right direction. All of this is why the console exists. The underlying backend infrastructure is the same as what Google uses for our own products. So, just finished explaining how Android Things is a fully managed solution. We have a lot more to show you at I/O. Come and see us at our Sandbox Dome. It's the giant bright orange one. It's hard to miss. The entire dome is filled with Android Things demos. You can see how real commercial products evolve from prototype to production, the smart displays. You can see them all there. We talked about devices getting increasingly smarter. We have demos showing machine learning, ingesting real-time video, so it can recognize emotions, faces, handwriting, and so on. By the way, you notice Android Things powering devices outside of the dome as well. They're powering the survey boxes all around I/O for instant feedback. There's a 5-foot-tall robot roaming around somewhere. It's hard to miss that one. Android Things in there. If you like to code, come to our code labs and get hands-on. We have one showing how to work with TensorFlow, Cloud IoT, how we made the survey box, and more. There's 8 more sessions coming up today and tomorrow that go deeper into specific topics. For example, the session at 11:30 today talks about how we built the smart display product, the journey all the way from prototype to production. The last session we have tomorrow talks about the console in detail and how to manage your devices at different stages of the development process. Finally, let's all have some fun at I/O. Join our scavenger hunt at the link g.co/iosearch. You might have seen this already. There's very cool machine learning enhanced flowers that you'll notice. Solve the puzzles and you'll get a free hardware developer kit. With that, let's all go build some hardware. If you know how to build an Android app, you now have a new superpower. You can prototype IoT products and bring them all the way to production with Android Things. You don't have to be a hardware engineer or firmware engineer to do this. Pick up a kit from the scavenger hunt, then head on to androidthings.withgoogle.com to get started. This concludes our talk. My name is Vince. Thank you, and good luck.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside. Thank you.
So with AI tools and machine learning, you can improve the yields, you can protect your crops, and you can have a much more reliable source of food.
AI offers the prospect to fundamentally transform the life of hundreds of millions of farms around the world.
You can see a product that can actually make someone's life better. This is kind of revolutionary.
So the whole point of the AIY projects team at Google is to build artificial intelligence kits that let makers take the cool parts of Google Intelligence and put them into their builds. Last year we released the voice kit,
Train fast.
which was a kit that lets you record your voice and analyze it and get the text back from what you said. This year we're releasing the Vision Kit. It does not need an internet connection. It does not need the cloud. You program it with the neural network model, and the kit then gives you back data on what it sees. So if I give it a face, the light will come on, and then as I get happier, the light will change from blue to yellow. So this is our MobileNets neural network. This is an object classifier, and it's got 1,000 different common objects in it. We have a banana, and let's see, a screwdriver. Yeah, it's got that pretty good. It's got an apple, not just an apple, it's got the type of apple as well, and even a water bottle, which is tricky because it is a clear thing, so it's not really a thing, it's just reflecting other things. So learning how to use these things and how to make it detect what you want to detect is going to be part of the fun. Our face detector code tells us not only that there is a face in the image, but it also tells us where the face is. It gives us the geometry about the face. So we can use that to build a tracker that can follow me wherever I go. We've shown you face detection, object recognition, and face tracking with the Google AIY Vision Kit. But this is just the beginning. Click on the link below to learn more. We're really looking forward to seeing what you build with this kit.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line, custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot, so it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year, so they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum, all the way from TensorFlow.js, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that compute to do cool stuff with.
Yeah, I mean, I think there's going to be a lot of different levels of expertise and experience in using machine learning. We want to make all of them able to use machine learning to improve their products and lives.
All right, so let's talk about what people are doing with machine learning as we're getting there. What are some things that people are doing in the world with machine learning that you're the most excited about?
Yeah, so there's like lots of different applications. One that I'm really passionate about is the use of machine learning to improve healthcare. I think there's a real opportunity there for both kind of medical imaging related problems. We've been doing a lot of work on diabetic retinopathy and other kinds of medical imaging problems, but also in how patients' lives are affected, how doctors are able to care for patients with making better decisions. A lot of advances there. It's going to be great.
Okay, so there's these big problems that we're tackling with machine learning. What about everyday problems? Is there something that you encounter every day that you would love somebody to apply AI to?
Yeah, I mean, I think as you start to have a machine learning lens as you walk around the world, you can see things that could be better. For example, when I pull up to a stoplight and it's red and there's no cars coming the other direction, that's just silly, right? We should have computer vision-based stoplights that just allow people to go when it's safe to go. And that would be like a simple improvement in the world that would improve lots of people's lives.
Thanks for joining me.
Thank you.
And thank you for watching I/O Live. To learn more about what Google is doing in AI and ML, head on over to google.ai. And to catch more videos like this, head on over to g.co/io/guide.
Cassava is a really important crop. It provides for over 500 million Africans every day.
When all other crops fail, farmers know that they could rely on their cassava plants to provide them food.
There are several diseases that affect cassava, and these diseases make the roots unedible. It is very crucial to actually control and manage these diseases.
So we're trying to use machine learning to respond to those diseases.
And TensorFlow is the best foundation for our solutions. The app that we've designed can diagnose multiple diseases. It's called Nuru, Swahili for light, the light that farmers can use to see their problems and find solutions. You wave your phone over a specific leaf, look at it, and if it has a symptom, a box will pop up saying you have this problem. When you get a diagnosis, we have an option for you to get advice and learn about the best management practices.
The object detection that we use through TensorFlow relies upon our team annotating images.
We've collected over 5,000 high-quality images of different cassava diseases for this project. We use a single-shot detector model on a mobile net architecture. It's able to make predictions in less than 1 second.
Instead of having to implement thousands of lines of code, TensorFlow provides a library of functions that allow us to build architectures in much less time.
We need something that can be deployed on a phone without any connection. TensorFlow is able to shrink these neural networks to be able to fit on your mobile device.
The human input is absolutely critical. We're really building something that augments your experience and makes you better at your job.
So with AI tools and machine learning, you can improve the yields, you can protect your crops, and you can have a much more reliable source of food.
AI offers the prospect to fundamentally transform the life of hundreds of millions of farms around the world.
You can see a product that can actually make someone's life better. This is kind of revolutionary.
So the whole point of the AIY projects team at Google is to build artificial intelligence kits that let makers take the cool parts of Google Intelligence and put them into their builds. Last year we released the voice kit, Train Fast, which was a kit that lets you record your voice and analyze it and get the text back from what you said. This year we're releasing the Vision Kit. It does not need an internet connection, it does not need the cloud. You program it with the neural network model, and the kit then gives you back data on what it sees. So if I give it a face, the light will come on, and then as I get happier, the light will change from blue to yellow. So this is our MobileNets neural network. This is an object classifier, and it's got 1,000 different common objects in it. We have a banana, and let's see, a screwdriver. Yeah, it's got that pretty good. It's got an apple, not just an apple, it's got the type of apple as well. And even water bottle, which is tricky because it is a clear thing, so it's not really a thing, it's just reflecting other things. So learning how to use these things and how to make it detect what you want to detect is going to be part of the fun. Our face detector code tells us not only that there is a face in the image, but it also tells us where the face is. It gives us the geometry about the face. So we can use that to build a tracker that can follow me wherever I go. We've shown you face detection, object recognition, and face tracking with the Google AIY Vision Kit. But this is just the beginning. Click on the link below to learn more. We're really looking forward to seeing what you build with this kit.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line. It's custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot. So it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year. So they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum. All the way from TensorFlow.js, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that compute to do cool stuff with.
Yeah, I mean, I think there's going to be a lot of different levels of expertise and experience in using machine learning. We want to make all of them able to use machine learning to improve their products and lives.
All right, so let's talk about what people are doing with machine learning as we're getting there. What are some things that people are doing in the world with machine learning that you're the most excited about?
Yeah, so there's like lots of different applications. One that I'm really passionate about is the use of machine learning to improve healthcare. I think there's a real opportunity there for both kind of medical imaging related problems. We've been doing a lot of work on diabetic retinopathy and other kinds of medical imaging problems, but also in how patients' lives are affected, how doctors are able to care for patients with making better decisions. A lot of advances there. It's going to be great.
Okay, so there's these big problems that we're tackling with machine learning. What about everyday problems? Is there something that you encounter every day that you would love somebody to apply AI to?
Yeah, I mean, I think as you start to have a machine learning lens as you walk around the world, you can see things that could be better. For example, when I pull up to a stoplight and it's red and there's no cars coming the other direction, that's just silly, right? We should have computer vision based.
Wow. Thank you. Good morning, everyone. My name is Reto Meyer. I'm a developer advocate here at Google. Now, technically, I'm a DA on the Google Cloud DevRel team. So if any of you bump into my boss or, really anyone from the Google Cloud team, and they ask how the presentation went, if you could tell them that I presented how to build a cloud backend for your mobile app, that would really help me out. Now, what I am presenting is hopefully what everyone is here to see, is Android Pro Tips, a fresh look at expert advice for advanced Android developers. As the title suggests, this will be a very technical talk. There will be a lot of code. If you're not comfortable with code, or if you came to hopefully see the Grateful Dead, you are in the wrong place. You're also about 20 years late. Now, just to get a feel to make sure we do have the right people in the audience, how many of you are developing for Android right now? Not now, but like at home and at work. Okay, most of you, not everyone. That's cool. Like there's some Android curious folks here, some deadheads in the wrong place and time. I think there's some folks up on the bank just working on their tan, and that's cool too. Everyone's welcome. Thank you for coming. Now, this is actually a pretty special year for Android. This marks the 10-year anniversary of Android development, which is super exciting. Obviously, not everyone's been developing on Android for quite that long. How many of you have been developing for more than 2 years? Yeah? Wow, most 5 years? A few hands down. What about 10 years? Do we have any 10-year veterans? A few. Nice. Congratulations. Yeah, round of applause for the 10 years. I too have that honor, that privilege of having been developing for Android for 10 years. I even brought receipts. This is my very first question on Stack Overflow. It's asking about the Maps API for the 0.9 Beta SDK, which those handful of 10-year veterans will hopefully remember, maybe hopefully not remember. This is not my first Google I/O. This is not my first pro tip session. So I'm curious, and this will be the last question I ask for a little while at least. How many of you have been to a previous I/O and seen one of my previous pro tip sessions? That's a decent handful. All right, and you still came to this. All right, that's reassuring. So thank you for that. I actually spent a fair bit of time over the last couple of months looking back over these sessions. And at first, it was because I wanted to gain some inspiration. You know, like, what are the cool things we used to talk about? You know, gain some of the excitement from the early days of Android. But I quickly realized that not everything that I had said in those early days has held up all that well. So as a result, what I'm actually going to be presenting this year is looking at all of the things that we've said in previous years and giving it a bit of an update. So the real title slide for today's session is actually Android Pro Tips Fixed. Sorry. So the goal here is to provide you with all the tips and tricks and best practices and good advice that's going to help us develop great apps for the next decade of Android development. And in order to do that effectively, I want you to take the same journey as me. So we're going to start by going back in time. We're going to go back through previous Google I/Os, previous pro tip sessions, all the way back to the very, very beginning. Okay, we may have gone too far back. This is me in kindergarten, happy child. I don't know what a fragment is, and I've never heard of a content provider. That will change. Also, side note, I didn't know I was presenting in the amphitheater and that there would be a 400-foot screen. If I had known that, I may have included fewer pictures of myself. Take note if you're ever in this situation. Clearly, we're too far back, so let's just bump it a few years forward. I think I can do that with one of these buttons. Let's have a look. Yes. Yeah, this is more like it. Don't I look young? This is 2008, and I remember this because this is actually the cover photo for my first Android book. And we took this photo just after I'd gotten the first round of editor notes back from the first draft. And the next day, Android released the 1.0 SDK. And up until then, I'd been writing based on the 0.9 beta, and I knew it was coming. You know, the clue is in the name. But I figured, how much is going to change, right? 1.0 from 0.9, 0.8 to 0.9 was pretty minor, so it should just be a couple of little things. Turns out a lot can change. Like, really a lot. I'd actually written an entire chapter on the Gtalk data API, which was pretty cool. But it did not exist in the 1.0 SDK. It was 30 pages of hard work. I didn't remove it. I ended up leaving it in the book because by the time it came out, who knows, right? Android moves quickly. Well, it's been 10 years. It never got put back in, and eventually I removed it from future revisions of the book. Anyway, the reason I mention this is because I've spent most of the past 10 years going around talking about Android, giving advice on the best way of doing things, the latest and greatest APIs that you can take advantage of to build great apps. And I do this with the knowledge that sometimes within months, even weeks, and these things are going to change. They're going to be replaced with something more efficient, more comprehensive. And in fact, weeks and months is a best-case scenario. I remember one particular incident. I had just finished a keynote, very exciting, Google Developer Day in Prague, I think it was. What's new in Cupcake? I've been doing this for a while. And I stepped off stage. And just as my foot hit the ground, we released Donut. So in that instance, I had about 3 nanoseconds of being current before everything I said was effectively outdated. Now, despite how all of that may sound, this is actually really a good thing. Well, for you, not so much for me, but for you it's a good thing. It demonstrates how quickly Android is evolving to take advantage of or to give users and developers the things that they need to be able to be successful. There's always been a trade-off, and I know you all have felt this pain, where a new platform comes out, awesome new APIs, great new functionality to take advantage of, but you know it's going to take a while before lots of users are on that platform. And at the same time, you know some of the older platforms are going to take a few years before they go away. So you have to do this trade-off. Is it worth putting in the time and effort to take advantage of the new APIs, the new functionality, knowing that it's going to have to be backwards compatible and you're going to have to maintain that code potentially for years? So when do you do that? Well, the thing is, what makes us really excited is that now we have Jetpack, right, which incorporates all of the Android support library, Android architecture components. And if you take Jetpack and combine it with Google Play services, we end up with an increasing surface area of APIs which don't rely on having the latest platform version. So you can take advantage of the new functionality that's available, and we'll take care of writing all of the boilerplate code to make it backwards compatible for you. Right, so this is a nice advantage, right? Suddenly that trade-off isn't quite as expensive. Now it's still, one of the big pluses of this as well is that we're no longer tied to the framework, right? So we can continue to launch new features, fix bugs, encapsulate more best practices, take care of more edge cases. We can do all of this in between platform releases, which is great for developers, not so awesome for those of us trying to talk about it. Things change more rapidly. But there's a price, right? If you want to take advantage of this cool new stuff, you'd have to reconsider some of the fundamental architectural choices in how we build our apps. And so I'm going to talk today a little bit about why I think now is the right time to do that. But if we bring it down to its real fundamentals, what we're trying to do is keep our app looking fresh, lightweight, full of potential. If not, we quickly risk becoming visibly older, outdated, a little bloated maybe, harder to maintain, harder to manage. And I don't know, there's an analogy for high cholesterol, but I couldn't figure it out. You get the idea, right? So before we sort of dive into some of the tips which we do need to update, I did want to spend just a little bit of time highlighting a handful of pro tips which have stood the test of time that, like a fine wine or a sharp cheddar, actually age pretty well. There's probably more than just the ones on this list, but this is the highlights. And what you'll notice about these particular pro tips is that they're not really specific to Android. They're not even really specific to mobile development. This is just good best practice that you should always be keeping in mind when building any engineering app. So let's not dwell too much on the things that we know are still good ideas. Let's take a look at some of the things which have changed, which have perhaps not aged quite as well. Now, everything on this list you can pretty much still do, but it's all been replaced with newer APIs that are more efficient, that encapsulate a bigger amount of functionality. Sometimes the underlying hardware's changed or the UI paradigm has changed, but a lot of it you can still do. And that's actually kind of a theme for a lot of the things that we're going to be looking at. There has always been ways of achieving certain things, but there's now significantly better ways. Simpler ways which involve less code, less hacky workarounds, making it more predictable and easier for you to maintain and manage your code bases going forward. So we know things have changed. I've said that a few times, but there's certain things we've always been able to rely on, right? You write your Android code in Java language syntax, and all of the application components are basically the same. You know, we use these same core components. They interact the same way. They achieve the same end results. And that's something we've been able to rely on basically until now. The last year or so, things have fundamentally changed. Android Studio 3 introduced Kotlin as a first-class language for Android development, and that's actually what we're encouraging people to use as their primary development language for Android. We saw the introduction of Android architecture components, which introduced view models, live data, and the room database to significantly simplify the way that we manage data and have it interact properly with the activity lifecycle. We also have the job scheduler, which almost entirely eliminates the need to create your own custom background services. And the intent receivers that we sometimes set up to monitor device state to control when our services are run, which is a good thing, because in Android O, we actually deprecated the ability to have long-running background services when your app is in the background as well. And at the same time, most of the intent receivers that you may have used to monitor device state have also largely been deprecated. Another good thing, of course, things move quickly. Job Scheduler already deprecated as of yesterday morning. So now we have Work Manager, which is nice because it does the same stuff as Job Scheduler, but it's backwards compatible, right? So you're starting to see some of the trends of what we're trying to achieve here. So we should dig into some of this stuff in a little bit more detail. It's something which I've talked about at most of these Pro Tip sessions. It was the first thing I talked about and comes up every year. I like to focus on what's happening in the background. Sometimes it's easy to miss until you really focus on it. So the first Pro Tip I gave back in 2010, first Android session, first real session on a big stage, was very exciting. And this is the first Pro Tip. So I thought, let's have a look at what I said and see how well it holds up. So this is the first thing I ever advised.
So it's important that you move anything which can in any way take longer than just a fraction of a second and interrupt the UI flow, that you move it into a background thread. So there's a number of ways you can do that. The most simple and straightforward is, of course, just to use Java threading. What we've created in Android is a class called async task.
Yeah, you know what they say, the giant screen actually removes 20 pounds. So it's kind of true, right? Kind of. We don't want to block the UI thread. The context around what I was talking about was trying to eliminate these application not responding dialogues, which have evolved over the years. They look a little bit different now. They used to be very common because it was easy to block the foreground thread, right? If you tried to do a data transfer, for example, it would block, and that would be a bad experience. And so for Android 3.0, we introduced a runtime exception. So if you tried to access the internet through a runtime exception, the app would crash. Strong encouragement for developers to not do that. More recently, we've done similar things with file system access, with database access as well. Now in Android P, this is no longer a problem because we don't show in-out dialogues. We just crash the app. So that's not a better outcome for your users, but it's a much stronger signal to us as developers that we need to make sure that we're taking care of this particular problem. Now, I did mention one solution, and it got some love, the old async task. It's a reasonable solution to the stated problem. We need to move everything off the foreground onto a background thread, and that's what async task does. Creates a background thread, and then it has these two handlers which are called marshal back to the UI thread so you can update the UI when you've got progress or a final result to display. I would like to tell you that the only thing missing from that is that now you have to write it in Kotlin. It's better. Kotlin looks nicer. It's certainly more concise. But you still have the same fundamental problems, where if you're doing this stuff within an activity, if the user rotates the phone, it's all going to go wrong, right? Your thread's going to get killed, your async task, and that's kind of your best case scenario. You may leak context. You may try and update a UI element that just doesn't exist, or is in the process of getting killed and recreated. It's problematic. Now, back in that first I/O session, I had a solution for this. It was a great solution. The advice was, you should move it to a service, which it's fair to say this advice has not aged spectacularly well. Now, the general principle is still pretty reasonable, right? It's like you have something long running. So you're in your activity, you use an intent to start a service, probably an intent service, and that goes and does the time-consuming work. Maybe it's pulling something down from a server or interacting with a database or performing some complex calculation. And when it's finished, it sends an intent back to the activity, and it then updates the UI accordingly. It's basic stuff, and it's a reasonable approach, but it does introduce some new challenges. services are heavyweight components, right? We don't really want to create them. We want to kill them as quickly as possible to gain back some of those system resources. And they keep running, even when your activity isn't, which is kind of the point. But now you have to keep in mind your activity lifecycle. What's it doing? Have you actually exited the app? Have you transitioned to a new activity? Should the service keep running? Should it be canceled? All of this stuff you need to keep in mind. And it's doable. It's just a lot of work to get right. And of course, because services run at a high priority, it actually prevents the system from killing your app to gain resources if it needs to. And there's no guarantee that your service will actually keep running if your app is force quit. So there's another problem, which is in Android O, you can't guarantee that your background services will be running when you want them to. You can't start a background service when your app is in the background from a broadcast receiver, and they will be killed after a few minutes, even if they were initiated while your activity was in the foreground. Now, for really time-consuming things, which you need to have run, this is still a reasonable approach. You have an activity, uses a service to then download data from a server, say. It's a nice time-consuming operation. And then that saves it to a database. And then your activity just monitors the database. So it's kind of a one-way flow, which is nice. But there is a catch. There's always a catch. And the catch is that this is not an efficient way to use the cell radio. And back in 2012, I'm not going to go into too much detail, but I had this whole spiel about how the cell radio works. And every time you do a transfer, it turns on the radio. It stays in a standby state, which draws more power. And the goal is that it reduces latency for future transfers. That's all great. And the reason it's important for us to know is that if you're doing lots of transfers, you can keep the radio turned on. It's going to draw power more quickly. And so we had some specific advice for this, which was you should deal with that. You know how it works now. Efficiency is important, so fix it. I had this whole metaphor to help. It was about cookies. I have a friend who's an artist, and this is an excuse to get him to draw things. And the idea here was to use the big cookie model, where you're minimizing the total number of transfers that you're using across the app lifecycle. So if you have something that's not time sensitive, like analytics, you queue that up and wait. Next time there's a user-initiated refresh, you send all of the queued data. You also look into the future to see, is there anything which is going to be scheduled to happen in a few minutes, and let's just do that first. So it was a way to manually batch and bundle all of your transfers so that they happen at the same time, and you get some increased efficiency. Now, as I'm sure you can believe, doing all of this and understanding how to do it right was complicated enough that a room full of engineers, much like yourselves back at Moscone, believed that this was a legitimate equation you needed to solve in order to figure out how to do this right. It's not. This is just made up. By 2012, we had a solution, which was the sync adapter. And the sync adapter, we claimed, was pretty straightforward, which is fair to say was a lie. Now, it's still better than doing it all yourself. Once you set it up, it's not that complicated, right? You're able to trigger a one-off or a periodic transfer, and the sync adapter will handle all of the background work, doing the batching and time shifting for multiple of your requests that happen within a sort of time window. So you don't have to think about when you trigger it, you just do and trust the sync adapter to handle the timing for you. Unfortunately, to make this all work, you needed to have a sync adapter, fair enough. Sync adapter runs within its own service. Of course, you also need to have an account manager, which isn't used, but it's part of the API. And the account authenticator also needs its own service to run in. OK, I'm seeing a trend. You also need to have a content provider. Again, doesn't need to be used, but needs to exist. You do all of this, write it all in Java, and then there's maybe a dozen XML files you need to write as well, plus some manifest changes, and then you're good to go. Your sync adapter works. It's fair to say that a lot of people trying to make this work found it to be kind of frustrating. And of course, it only batched and bundled your your transfers within your own app, which is why 2013, great year, Android 5, we introduced the Job Scheduler API, which has now been replaced. Job Scheduler works at the platform level, so it does the batching and bundling for all of the apps. at the same time to be able to take advantage not just of cell radio battery improvements, but all of the resource improvements that we're trying to do, things like standby, doze mode, all of this. So within your app, you create a new job service that does the asynchronous background updates. In this case, we're using the async task, which we can use now because we don't have the same memory leak problems. And then within your specific activity, you just define the criteria that you need in order for that job to be successfully executed. If it needs to be on the internet, it needs to be charging, etc. How urgent is it? What is your preferred timing? Is it periodic? All of that sort of stuff. And the job schedule will then handle all of the background work for you in the most efficient way possible. The only thing which would be better than the job scheduler is if it worked in a backwards compatible way, which is why we launched Work Manager, which is part of Jetpack. Now, to use Work Manager, it works basically the same way. You create a new worker, and that is where you're defining the background work that needs to be done. And then within your activity, you do the same thing. You specify the constraints that need to be met before this work can be accomplished. And then Work Manager will handle all of this for you in the background, same as Job Scheduler, but it now also encapsulates the best practice solution for earlier platform releases. I think it goes back to 4.4. So it'll use the latest and greatest Job Scheduler if you're running on the latest platform, all the way back to probably Alarm Manager for some of the earlier platform releases. And again, you don't need to write any of that boilerplate code for backwards compatibility. We do all of that for you. So you don't have to maintain it, find the bugs, find the edge cases. You can rely on Work Manager to take care of that. And of course, this is going to continue to improve in future releases. So as Job Scheduler continues to improve on the platform, Work Manager is going to be able to evolve to take advantage of some of those changes. You can learn all about Work Manager and Stage 2 today at 5:30. I recommend going along. It's a really cool new API. So Work Manager, it's great if it's something which is genuinely time-consuming and it needs to be initiated on the client side. Now, one of the things which we've always said and which really hasn't changed is that wherever possible, you should eliminate periodic refreshes, and any updates that need to happen based on changes on the server side should be initiated by the server, preferably using Google Cloud Messaging, by which, of course, I mean Firebase Cloud Messaging, because GCM was deprecated in April. Things move quickly. Now, Firebase Cloud Messaging takes advantage of the same scalable, reliable GCM infrastructure that we've been using in the past, but also improves delivery reporting and reliability. It also adds a web console so you can send notifications to your apps without having to have your own server instance. Now, for transfers, this gives us a pretty good solution, but there's really no way that this is a viable solution for being able to maintain a small amount of data whenever the phone rotates. And for that matter, using singletons or overriding the application class, which I may or may not have said in previous years, is similarly considered somewhat distasteful. So, which is why in Android 3.0, we introduced headless fragments and loaders. I assume everyone's familiar with both of these. Fragments were designed to break your UI up into chunks that were independent, reusable, and interchangeable. And the key here was they were also aware of the parent activity lifecycle. Now, the trick with headless fragments was that they didn't have a UI. So you could configure them to be retained across an activity restart based on a configuration change. And this is really nice because it meant now we have somewhere to store our data model that's independent of the activity being recreated every time the configuration changes. But managing fragments was tricky. And if you attended the first Android session this morning here, you see just how tricky it was. You can add and remove fragments from any activity. You can have multiple instances of the same fragment within the same activity. The fragment transactions are all done asynchronously, so you can't guarantee when something is there. And it's got its own lifecycle to manage. Now, none of this was great. Right? You were able to achieve what you wanted, but it was complicated to make this all work. Now, loading was better. Loaders made it easier to asynchronously load data within your fragments and activities. And then you could observe and react to changes in the loader within the activity. based on whenever the underlying data changed. And in most cases, you had to handle all of that plumbing yourself, which meant you needed to load the data from wherever it was stored. You needed to then observe changes within that underlying data and bubble it back up through the loader so that you could have the simple code in your activity, which was unless you used Cursor Loader. Now, Cursor Loader was great because it did most of the work for you. You initialized the loader within the activity or fragment at creation time, and then you just filled in a number of callbacks to create a new cursor and then to receive the results so that you can update the UI accordingly. Now, initializing a cursor loader was pretty straightforward. You pass in the authority of the content provider that you want to query and the SQL statement that you want to use to get back your results. All of that gets passed into a content resolver, goes to your content provider, and gets you back a cursor, which you can then use to update your UI. But by definition, that meant that you needed to make your data available via a content provider. And content providers are, actually, you know what, I'm going to come back to content providers. I'm just going to leave them there for a moment. So, OK, so take a step back. We've got headless fragments and loaders, and technically that enables us to do everything that we need to do. There's a problem, though. It's really hard to get them to work together, understand how to make them work across multiple activities and fragments and the various different implementations of both. In fact, getting it all to work reliably and well was, again, it was frustrating, which is why we're also excited to see Android architecture components. Android architecture components introduce view models, live data, and the Room database. And this all effectively replaces fragments and loaders as a simple way to separate your UI and your UI data. The view model itself is actually really simple to create. You start with a property that stores the data that you want to expose. In this case, we're using a mutable live data, because live data is cool. And then you expose a method which is going to return that property. And so the first time it's going to populate that property, and then from then on it will return that cached version. Then you have a method which does that population. And again, this is done asynchronously. In this case, again, we're using our old friend, the asynchronous task. Then whenever the value of your mutable live data changes, that is going to trigger any observers that you have attached to it. So back in your activity, all you need to do is request the view models, ask for the specific view model class that you've just created, and then call that view model's data access method, which will either then populate the data and return it. Either way, you'd add an observer to that, and then your observe trigger is going to get called both the first time you attach the observer and then any time the underlying live data changes. Now, the beauty of view models is that they survive activity restart, so we don't have to deal with that particular scenario. And the beauty of live data is that it understands the activity lifecycle. So the first time the app is run, your view model gets created, populates the live data from the underlying data source, sends the results back via the observe handler within your activity, and then, if someone rotates their phone, the activity gets destroyed, gets recreated, but the existing view model is returned. The existing live data is returned via the observe handler, and it's triggered with the latest version of the data, whether it's been updated or not in the interim. In fact, live data is really smart because it only sends updates via the observe handler when the activity is active, because you don't need to update the activity if the UI isn't actually visible. And if there is new data, it will wait and then transfer it once the activity becomes active. But as a total result, what we do is we feel less like this and much more like this, which is always our goal. Content providers. I promised I'd come back to content providers, and just as some context, this is what happens. This is the number of students enrolled in each of the lessons of our Android Udacity class. And as you can see, the highlighted columns are when we get to content providers and loaders. So you get the impression this is something that people find a little frustrating. We've improved it since then. It's not quite so grim now. And some of what we're going to talk about now actually explains some of those improvements. Why is it so frustrating? Well, this is the boilerplate code for creating a simple content provider. I'm sure many of you have built something like this. In truth, it's really just the first couple of methods. it goes on for a little while. And now, keep in mind, this isn't doing anything particularly special. It's just passing content resolve requests straight through to a SQLite database. Now, obviously, that's just the content provider. Then you need to create a contract that defines the column names that you want to use to be able to interact with it. Then, of course, you need to create your own SQLite Open Helper, which is how you create, update, and access the underlying database. Now, all of this operates on cursors, which is probably not what you're using in your UI. So you'll need to create a class to represent the records in the database, which is nice. It's actually quite simple in Kotlin. But you'll also need code to convert between those class objects and content values to add rows to your tables. And you'll need to be able to convert between cursors and lists of your class objects. Somewhere along the line, you need to set up a bunch of observers so that if the database changes, your list of objects also gets updated. It's a lot of code for something which should be relatively straightforward. Quick one, is there anyone here who gets paid per line of code? No. OK. So if there is, and you were just too shy, that old method actually works really well. Stick with that. For the rest of us, this is where the Room database really comes into its own. So as it's part of Android architecture components, now part of Jetpack. And all you need to do is you start with the class definition, right? Defines the columns that you want within your class. And you just add an annotation to say, this is an entity that I want to use in a database. And this is the primary key for this table. Then you create a new Room database, which includes each of the tables that you want to have within that database. And you return an instance of the data access object. And that is the class where you specify all of your database interactions, your inserts, deletes, updates, and your queries. As many of them as you want in as many different styles as you want. Now, you'll notice that the queries here return live data. And that's really cool, because if you're storing your UI data in your view model, which obviously you are, because that's the right way to do things now, it actually simplifies that view model significantly. You just request access to the Room database's access object, execute the query, which returns live data itself. Then you just pass that live data right back through to any activity or fragment which requests it. Back in the activity, it works the same way. You've got the same observe handler, getting the same live data representing a collection of objects, and you can use that to update the UI whenever the underlying database changes. So you've got the same outcome that you did before, but 10 times less boilerplate code. 10 times less code that you have to maintain and alter. If you change a column name beforehand, it was a lot of places that could go wrong. Now you just modify the class. Now, if you combine that with the Work Manager, you actually get a really clean solution to this whole process, right? The Work Manager downloads data from a server. It updates the Room database accordingly, which then sends the live data to the view model within the activity and fragment or fragment that you want to use, which then by the observe handler updates the UI. Right? So if you're not one of the lucky folks who are still getting paid by line of code, this is probably a better solution. Right? So speaking of better solutions, what else have we got? I wanted to talk a little bit about Android location services, because this is, again, a topic that I spent a lot of time talking about. Being able to find the current position and put it on a map somewhere is something that's been part of Android since the very first Beta SDK. And so by 2011, I'd actually managed to amass quite a collection of pro tips for how to take advantage of the location manager in the most efficient and effective way possible. It was a big topic in a couple of my Android pro tips talks. So I went to the location team and said, I've built a project which encapsulates all of our best practices, all of the things which we tell people to do. And it's fair to say that they were impressed, by which I mean it really left an impression. They then went away and did what they do, which is fixed everything. And so where beforehand I had all of these classes and interfaces, they went away and gave me an API as part of the Fuse location provider, which does all the magic for you. It encapsulated all of those best practices within a small number of simple APIs. All you need to do here is tell it what's more important, battery life or accuracy. How often do you want to get results? And the Fuse location provider goes and does all of the hard work for you. Now, that said, things have changed a little bit. In Oreo, we made some changes, some new restrictions about how you can receive location updates while your app is in the background in order to save battery life. And specifically, that means that if you are in the background, you only received updates from Location Manager or the FLP a few times an hour. There's a few ways that you can deal with this, right? You can make a foreground service, which is what we do with navigation. Another approach is to use geofences. So for those of you who remember the very first version of geofencing on Android were proximity alerts. Proximity alerts were bad. Easy enough to set up, specify a lat long, a radius around a point, and they would fairly reliably trigger if you went across that boundary. Now, the challenge was the way that it achieved that was by turning on and leaving on your GPS. So as long as you had a proximity alarm set, it would keep the GPS running permanently, which is not what the documentation said, but it is what happened. Now, luckily, the same Google Play Services launch, which gave us the Fuse Location Provider, also gave us a real geofencing API, which had all the functionality that was claimed from that was claimed to be done with proximity alerts, but also gave you a few additional improvements. Most important of which was that it didn't keep the GPS locked permanently on. We can take our geofences to the next level with the Awareness API, which adds additional context signals which allow us to make more complicated fences. Specifically, we can add date and time, proximity to beacons, user activity if they're walking, cycling, driving, and device state. And you can combine all of those conditions together, such as in this example, where we have one fence which is triggered if you drive within 1,000 meters of a given location between 10 and 6. We have a little bit of time left. One thing I learned in 2018 is that there's a new way to, oh, I'm sorry, that should be, there's a new way to control media. Right. Now, back in the day, controlling media playback was done with the media player. I'm going to buzz through this pretty quickly. Mainly, it meant that you had to listen to media buttons getting clicked. Now, of course, you can control media a bunch of different ways. So we've got a better solution, which is ExoPlayer, which effectively replaces the framework media player. It's easy to customize and extend. Again, I'm not going to go through the full details here. I had a couple of slides, but I have been speaking too slowly, so recommend that you go to Mark and Andrew's talk tomorrow morning at 10:30 to get all of the details. Now, not all of the changes in Android have been in code. Some of the biggest changes are actually in the availability of Android expertise. Back when we started, we didn't have Slack and Google Developer Experts. We didn't even have Stack Overflow. What we did have was IRC, we had Google Developer Groups, we had some DevRel people which spoke at conferences, and that still kind of happens. But the big change now is that we're just voices within a much larger developer ecosystem. There are now lots and lots of people around the world who help each other. This is just a small selection of the 90 Google Developer Experts specializing in Android and Kotlin all around the world. So there's just a small amount of the extended engineering team that we have helping the community. Similarly, we've got Android conferences all around the world. This is a small selection of some of the Android events that people pointed out to me on Twitter a couple of weeks ago when I asked what the best conferences to go to were. Because really, the biggest tip that I can give you is that much more than changes in the tooling or the frameworks or the APIs or Jetpack or anything else, much more than that, the biggest thing driving Android development forward is the community. It's the people around you, the people online, who are all helping each other with Android. And it's important because we know that the one thing that doesn't change is that things are going to change. So take advantage of things like Jetpack to make things simpler, work with the people around you, and hopefully your apps will survive much longer than my pro tips. Thank you.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside. Thank you.
Design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class using Black Panther as an example of sort of our vibranium and our, you know, sound science that we use in the movie. And to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and, yeah, I can do this is, I mean, you can't ask for anything more. And so, you know, I've always thought, like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, you know, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good,
yeah.
Right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, you know, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud and that, you know, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So you know, and then after when I saw it, I was like, I mean, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, you know, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like, but it was certainly always about making a good movie with a great story, and hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, you know, because a lot of what she did in the foreground on the characters defined who they were on screen. So that also gave back to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on their feet. That's a whole nother sense of representation and a social aspect for young kids, young girls, and the men who, you know, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You know, you saw the door fight. You saw the king treat them as if they were, when they were the most powerful, you know, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. You know, very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was, and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. And I think technologically, oftentimes, it is the thing for the thing's sake and not here is, you know, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together. And then pulling from nature. That was a huge one. And thereby keeping everything organic, in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, you know, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, like my whole team put every last inch of themselves. So, you know, it was a beautiful thing because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda. I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes, I've read the entire series. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, And then overnight, they'd rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab, and I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All three of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, is part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
This is IO Live, and I'm Timothy Jordan, and I'm standing here with Hannah Beekler, who is a production designer. You may know her from Black Panther.
Hello.
Hi, how are you today?
I gotta give it one of these. Great, I'm doing great. I'm so happy to be here.
Me too. We're really glad that you came here to talk about your work and to talk about diversity and inclusion and how that's affected by representation in media.
Absolutely. I mean, I think a big important part of that is if you don't see it, you can't be it. And so putting those things into our narrative work and films, which, you know, everybody finds the time to go see a good movie, as noted by Infinity War, and, you know, and to represent a huge portion of the, you know, population in that way. I think when people see it, they realize, like, I can do that. I can have those same goals in life, because it's not going to be impossible. And I think that that's such a huge, important part of my work, in my body of work over the last 3 years.
Yeah, one of the things I think about a lot is that I was really lucky growing up, wanting to be an engineer and seeing lots of engineers that looked like me. And that was inspiring, and I really want that for everyone.
Absolutely. I mean, I think inspiring the next generation of young scientists who are females, young kids of color, who see a world where they have a sense of pride, where they have a sense of, you know, reaching back and seeing their tradition and their culture and their ancestors and all those things, even being a part of their future. And I think walking away with a huge sense of themselves that they otherwise may not know or have had privy to, or so it's lifting spirits that's so important when it comes to representation. It's not only about getting into certain fields; it's about who we're raising in the world for the future, because I know I'm going to be relying on my young child to take care of me, and I want him to know some things. So, you know, it's always on my mind, and it's something that I think I'm now more than ever driven to do and include as part of my design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class using Black Panther as an example of sort of our vibranium and our sound science that we use in the movie, and to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and yeah, I can do this I mean, you can't ask for anything more. And so I've always thought, like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good,
yeah.
Right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud, and that, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So and then after when I saw it, I was like, I mean, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like, but it was certainly always about making a good movie with a great story, and hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, because a lot of what she did in the foreground on the characters defined who they were on screen. So that also gave back to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on their feet. That's a whole nother sense of representation and a social aspect for young kids, young girls, and the men who, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You saw the door fight. You saw the king treat them as if they were, when they were the most powerful, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. Very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers.
Good morning. It's great to see everybody here. Hi, I'm Lucas Bergstrom, product manager for Android Architecture Components. And before I get started, I'm curious, how many of you were here last year when we announced Architecture Components for the first time? Awesome. Okay, this is a much bigger venue, so that's actually a decent percentage. When we did launch architecture components last year, we were doing something sort of different for us. For the first time, we were offering explicit guidance in how to architect your app and giving you components, letting you do that. And frankly, for us, it was a little bit of a journey into the unknown. So 12 months in, let's check in on how we're doing. So we've shipped 26 releases since May of last year. So we've been constantly iterating and improving on the core set of architecture components. In the sign of any healthy open source project, we have a very active issue tracker. I'd like to thank everybody that's taken time to file a feature request or even a bug. And we've closed a lot of those. We launched a major new library, Paging, which is now stable, and we'll talk a little bit more about today. And I'm pleased to say that based on our survey data, over half of you are using or planning to use architecture components. And this survey was done only a few months after we went stable, so this data is pretty out of date by now. But I'm pretty proud of the fact that only a few months after launching to stable, over half of the Android developers we talked to were planning to use this stuff. But more importantly than any of this, you've told us that architecture components actually make it easier for you to build robust apps. That having a clear path on how to architect your app and components that help you realize that has actually made a difference in the real world in how you build your apps. And we've heard that not just once, but we've heard that over and over from a lot of developers that have taken time to speak to us. So architecture components has grown, and we're going to continue to invest here. This is foundational, we think, for Android apps going forward. But not just are we investing in architecture components, but this year with Jetpack, we're going to take that same approach that we took with architecture components, a blank sheet of paper approach to how Android developer experience should be and how we can improve things for you. And Jetpack is going to take that and apply that to the rest of the developer API service that we offer. So now I'm going to turn it over to Yeet to talk about what's new in architecture components.
Thanks, Lucas. Thank you. So we will talk about what we have been doing in this last 1 year. We'll look at the existing libraries, talk about the improvements, and also look at the new shiny stuff, paging, navigation, and work manager. Let's start with lifecycles. So we have shipped lifecycles in the last I/O, but to better understand why we have created this component, let's go to 2 years before. In 2016, we did a bunch of developer surveys and asked developers what is the hardest part of Android development. And by far in the list, big surprise, was lifecycle management. We're wondering, what can be hard about a phone rotating or user switching applications? This happens all the time on Android. Android is built for this. But if you look at the problem in detail, if you want to handle them properly in your application, you need to understand these state graphs very well. And when these two are interleaved, it becomes very confusing. So we have created Lifecycles component to get rid of these problems. And it seems to be working because many developers give us testimonials where a group of problems just disappeared from their applications when they started using these libraries. Another important change for Lifecycles was 1 year ago, we have introduced them as an optional library. But now they are a fundamental part of Android development. You don't need to do any additional libraries to start using them. Now, both AppCompat activity and the Fragment class implement Lifecycle Owner out of the box. Another interesting thing that happened was the community adoption. So we ourselves create new APIs that works with Lifecycles, but we do other people doing the same in their libraries. And this is so much easier because already AppCompat has these dependencies, so you can easily depend on them in your libraries. One great example of this is the AutoDispose library from Uber. So if you're using RxJava, but you want the automatic lifecycle management, you can just add this auto-dispose comment to your stream, give it a lifecycle, and it will manage the subscription for you for free. Now, working on these things, we have also discovered more problems we have. One of them is the FragMass view lifecycle. Now, FragMass has a very complicated lifecycle. Let's look at an example. So if you have a fragment that when it's created is observing live data, it goes through the regular creation, we create a view for it, and it goes to the resume state. At this point, if you have new values in your live data, your UI will start displaying them. Everything works fine. Later on, user hits a button, so you want to detach this fragment because they're going to another fragment. And we're going to stop that fragment. But once the fragment is stopped, we don't need to view for it. We would like to reclaim those resources. So we destroy the view. Later on, user hits the back button. You go back to the previous fragment. We reattach it. Now, because we have destroyed the view, we need to create a new one. We go ahead and do it, but it's a brand new view. It goes through the regular creation cycle, and now we have a bug. This new view will never resume the state of that live data because you are using the FragMass lifecycle to observe it, so we don't have any reason to redispatch the same value. Of course, if live data receives a new value, the UI will be updated, but it's kind of too late because on recreate, your UI has a bad state. Now, this left you with two options. You would either subscribe in on create. It looks very clean, one-time setup, but it will fail if you recreate the view, so you needed to manually update the view. Or you would subscribe in on create view, which handles the creation, but now you have double subscriptions that you need to remove. You lose the automatic lifecycle management. So the problem here is that FragMass have not one, but two lifecycles. And we have decided to embrace it and give the fragment view its own lifecycle. So now, starting in support library 28 or Android X Fragments 1.0, while observing a live data, you can specify the view lifecycle. And so while you're observing, if it is about the view, you use the view lifecycle. Otherwise, you use the fragment lifecycle, and we manage the subscription for you for free. OK, data binding. So when we started to look at our offerings as part of Jetpack, we have decided to move data binding as part of architecture components. But if you're not already using data binding is our solution for boilerplate-free UIs. So if you have an object like this in your application, in your binding layouts, you can reference the fields in your object, and we take care of updating the UI for you. In data binding 3.1, we have added native support for live data. So if you have a view model like this, which has a live data of a user, and if you pass it as a parameter to your binding, you can use that live data as if it's a regular field in your binding expressions. Data binding will understand that it's live data and generate the correct code. Unfortunately, this is not enough for it to observe it because data binding doesn't have a life cycle. To fix that, when you get your binding instance, you just tell it which life cycle it should use. It will start observing the live data, keep itself up to date. You don't need to write any code for this. We have also rewritten parts of the data binding compiler to be a lot more incremental. So if you have a project with multiple modules, it's going to compile a lot faster. We're also working on making the compilation even more incremental, but they're not finished yet. This new compiler also gave us the ability to support instant apps. Now you can use data binding in the feature modules of your instant apps. OK, Room, my favorite architecture component. So Room is our solution for object mapping that binds the gap between the SQLite and your Java or Kotlin code. One important change we did in Room 1.1 was the support for better multi-threading. So if you are using Room 1.0, and if you have one thread that's trying to insert a lot of data into a database, and you have another thread that's trying to read data, while the write is executing, your read will be blocked. And it can only execute after the write is complete. In Room 1.1 with the write logging, they can run in parallel now. And another nice feature of this thing, your writes run a lot faster than before. Best part of this change, you don't need to do anything to take advantage of this. If the device is running Jelly Bean or newer, and it's not a low memory device, we are going to enable write-ahead logging for free. OK. Another important addition to Room was the support for raw query. But to better understand why we needed raw query, let's talk about the query annotation. Now, when you're using Room, you can specify your SQL query in this annotation. You can use the named bind parameters. You can pass those parameters as regular function arguments. And you can tell Room what to return. The best part of this setup is that Room is going to validate all of this at compile time. So if there's a mistake in your query, if your parameters doesn't match, or what you try to return doesn't make sense, it's going to fail the compilation and let you know what is wrong. Now, this is all cool, except what if you don't know the query at compile time? What if you're writing a real estate application where user can search the houses with the price? Maybe they want to specify number of bedrooms, bathrooms, whether it has a yard. If you needed the query method for each variation of this, that will be impossible to maintain. So what you do in this case is you create the query at runtime based on the options user provided, and you prepare the arguments for that query. Then you obtain an instance of the Room database and use this query method to get the result. So far, so good. The problem with this approach is that it returns you a cursor. Who wants a cursor? You're trying to get the list of houses. So this looks like a failure of the library. Hence, we have decided to introduce raw query annotation. It looks very similar to query, except instead of specifying the query in the annotation, you pass it as a parameter to the function. And then you tell us what you want us to return. Now, here, Room cannot validate that query anymore. So it's kind of you promise us to send the right query, and we'll take care of it. Once you have that, if you go back to our previous example, we can get an instance of our DAO. Now, we need to merge our parameters and the query in this simple SQLite query class, which is basic data holder. And then you can pass it to the DAO and get the list of houses. No more cursor, no more boilerplate code. OK, paging. So paging is our solution for lazy loading in RecycleView. But to better understand why we developed this component, I want to go through an example. So you have a list like this. It's very common. Every single application has this. User can scroll. But you know, it actually represents a much larger list than what's on the screen. And if you're an application like Twitter, for instance, it's a very, very long list. So you probably cannot fit it in memory, and it's also very inefficient to load all of it. So what you would do is you would keep some of it in memory, the rest of it in database, and you also have your server component where you pull this data from. Now, this is actually very hard to implement properly. That's why we have created the paging library to make these common flows very easy and efficient to implement. Paging library comes with a pagelist class, which is an actual Java list implementation, but it works with a data source. Every time you access the items in the page list, it pulls data from the data source lazily. So if user scrolls, you need more data, it just brings them more data. Now let's look at how we can get an instance of these classes. It's actually super easy if you are using Room. So Room already knows how to create a data source. It's a great example of how these architecture components work very well together. So you can just tell Room to return you a data source or a data source factory. In this case, I'm using a data source factory because database is something that changes, and each data source represents a snapshot. So we need a factory so that we can create new data sources when database changes. Once you have that, you can use this live page builder class, pass the page size, and call build on it. It's going to give you a live data of page list of users. This is almost the same thing as live data of list of users. Now, in your activity or fragment, you would use this page list adapter, which is a RecycleView adapter that works with page list. You would observe the live data every time you have a new page list, give it to the adapter. And then inside your adapter, you can just call this getItem function to obtain the user object. This is a super simple code to write, and we take care of all the hard work of paging it lazily for you. Now, even though I have shown all those examples with live data, paging supports RxJava out of the box. So if you are using RxJava and you want an observable of page list, you can just get the same factory that Room generates, but instead use the Rx Pages builder to build your observable or flowable. Now, paging supports paging from the database, as I have shown here, but it also supports paging from the network, or you can combine both database and the network for the best user experience. To learn more about it, please join me and Chris Craig tomorrow at 2:30 in the paging session. All right, now about Foo.
I think possibly some of the suspense about what Foo is gone now, but yeah, when you think about sort of core problems that almost every app has to deal with, in-app navigation has to be close to the top of the list there. Right now, the framework doesn't really offer anything for you to do, anything for you to use there other than start activity, which for various reasons is not the best option. So that means that for navigation, there are a bunch of things that you have to figure out on your own. And that ranges from executing a fragment transaction without throwing an exception, hopefully, passing arguments from place to place, possibly even with type safety, if you can figure that out. Testing that navigation is working and that the right things are happening when you navigate from place to place. Making sure that the up and back buttons work correctly and take the user where they're supposed to go. Mapping deep links to destinations in your app and having that work. And by the time you've solved all of these problems, you've typically gone one of two directions. You've either written 60% of a navigation framework just for your app, or you've got a lot of error-prone boilerplate. So everywhere navigation needs to happen, you've got a bunch of parallel lines of code that need to be changed anytime the navigational structure of the app changes. And this is all pretty brittle and can end up being a headache. And individually, these problems are pretty tractable, but when you compose them into a real-world example, so say that I have an item screen in my app, maybe a product screen, and that screen is accessible via deep link. But actually, there are other pages that, if the user had navigated here by opening the app from the home screen, they would have come via the home screen, the category screen, and I want the up button to take them through those screens rather than exiting the app, right? So that means that if someone deep links into the app, I need to synthesize these screens and add them to the backstack, but only on a deep link. And talking to a third-party developer, he said, it's when you're in the middle of writing code to do this, on any deep link into my app and synthesize the backstack correctly, you start to feel like maybe this is a failure of the framework. And so that's why we're really happy to be launching navigation, which is both a runtime component that performs navigation for you and a visual tool that works with XML to define the navigational structure of your app and then allows you to just navigate at runtime with a single navigate call. And so the kinds of things that you're going to get for free, right, that you simply need to define in XML and then the navigation framework will handle at runtime for you are animations, passing arguments in a type-safe way from place to place, making sure that up and back work correctly, and mapping deep links to various screens in your app. And last but not least, no more fragment transactions ever. So I'll show you a couple demos of this in action. The first one is just to kind of give you an idea of what this all is. So we're looking at a set of fragment destinations in my app, and I'm adding a new one, and now I'm creating an action. And this action is the thing that I'm actually going to call at runtime to go from place to place. And you can see that there are a bunch of other options that we'll get into more in the navigation talk. But the one thing I do want to show you in more detail right now is the example we went through before. So this is a simplified version of that where there isn't a category screen. We just have the home screen and then the item screen. But I'm going to, right now, configure this to both have a deep link pointing at the item screen and make sure that if someone deep links into the app, that they go to the home screen first when they hit up or back, rather than just exiting the app right away. So first, I'm just going to configure a deep link on this screen. And the curly brackets that I'm going to put around item ID indicate that I want to extract a variable there and pass it as an argument into the item screen. OK, and now that's ready to go. And if I compile and run my app, that'll just work and navigate to the right destination. Now I just set the home screen to the start destination. That means that it's the hierarchical parent of all the other screens in the graph. So when someone deep links into the item screen and then hits up, they're going to go directly to that home screen. So now I've just solved in 30 seconds what would have been a really terrible and time-consuming task in Java or Kotlin back in the old world. So now I'm going to pass it off to Yeet to talk about Work Manager.
I've been using navigation a couple of weeks for some demos. It feels like magic. So I hope you all liked it. Our next architecture component is Work Manager. Now, Work Manager is our solution for deferrable guaranteed execution. What do I mean by this? You have a lot of actions on Android that you really, really want to do if user does something. For instance, if user tries to send a tweet, you want to send it now, but if there is no network connection, you want to send it as soon as device is connected to the internet. There's things like uploading logs you may want to do if the device is charging, or you may want to periodically sync your data with your backend. Now we know this is not a new problem on Android, and we had some solutions for this. We have introduced Job Scheduler in Lollipop, and we have Firebase Job Dispatcher that backports this functionality in the devices which has Google Play services, and we also have Alarm Manager for exact timing. Now each of these has different behaviors and different APIs. It becomes very hard to implement. Hence, we have built Work Manager that sits on top of them and provides a much cleaner API with new functionalities. Work Manager has two simple concepts. You have the workers that execute these actions, and you have the work requests which trigger these workers. Now, if you want to look at a sample worker, this is basically all you do. You extend the worker class, you implement one function that says do the work, and that function just needs to return us what happened as a result of that work. So you can do whatever you do, and you return the result. There's no services, no intents, no bundles, nothing like that. Once we have the worker, we need to create a work request. So you can use this one-time work builder, or there's a periodic version of this one. You can specify the worker class. But now you can also add constraints. You can tell it to only run if there's network connection, if the device is charging, or you can specify a backoff criteria. So if the worker is failing, how should we retry it? You can also pass input parameters to these workers. Once you build that work request, you can get an instance of Work Manager and enqueue it. Then Work Manager will take care of executing it. One of the important distinctive features of Work Manager is that it has input and output semantics. So your workers can receive input, but they can also output some data. You can observe this data through Work Manager, but it's actually very useful to chain your workers. So imagine you have an application where a user picks an image from their device, then you want to run some image processing on that picture, and then once it's done, you want to upload it to your server. Now, these are two different units of work. Like, you can process the image. Maybe you want to do it when the device is idle, or you can do it anytime. But to upload it to server, you need internet connection. But you don't want to wait the processing for the internet connection because it doesn't need it. This is super easy to implement in Work Manager. So we'll have two different workers. They'll have single functionality. One of them does the image processing. The other one does the upload to server. We'll create a helper function that receives an image file and creates the process image work request. So it prepares the input, just uses the same builder to produce the request. And now we get that. Now we wanted our network upload to wait for the internet connection. So we set a constraint. We say, OK, wait for internet connection before trying to run this work request. And then create the upload image work using that constraint. Once we have them, you can tell Work Manager, OK, begin with the process image work. Once you are done, then run the upload to server work. And then you enqueue both of these as an atomic operation to the Work Manager. Then your device can restart. Anything can happen in between. We will take care of running the two. You can also use this API extensively. Like you could run image processing in parallel the same way. So if user pick multiple photos, you want to process all of them, but upload it to server once all of them are done, you can easily do that with Work Manager. We'll just use the same function. We'll create 3 work requests for each of the images user picked. We create the upload work image the same way we did before. And then we say, OK, begin with all these 3 work items. Once all of them are done, then run the upload work. And then you enqueue that as an atomic operation. And it takes care of running it. Another important feature of Work Manager is that it is not just a wrapper for job scheduler or Firebase job dispatcher. It's actually an executor itself. So let's look at why opportunistic execution is important. So if you're an application where user can send an email, so user hits the send button, you send the job info to the job scheduler or to the Firebase job dispatcher, and it will eventually call you to execute it back. The problem here is that you don't know how long it will take. Even if your device currently has network connection, it may take a couple of minutes for job scheduler to call you back, and you have no control over it. You just don't know. And it results in a bad user experience. To work around that, what you usually do is you also have your own thread pool. Whenever user hits send, you try to run the same thing there as well, and you take care of deduplicating when the job scheduler calls you back. If you are using Work Manager, you don't need to think about it. Because when you send a work request to the Work Manager, it puts it into its own database. Then it tells job scheduler or whichever scheduler it has on the device, OK, I need to be invoked when these constraints are met. But it also checks those constraints itself. And if they're already ready, it will instantly start executing the job. And later on, if job scheduler comes and asks it to execute, now Work Manager knows whether it is executed or not and handles the request properly. To learn more about Work Manager, please join us today at 5:30 in the Work Manager session. All right, what's next?
OK, so I think it's been a pretty great year in Android app development. Hopefully you agree. We launched a set of great new components last year, and we kept working on those and iterating on those. We've launched 3 new major components, Work Manager, Navigation, and Paging since then. So does that mean we're done? Obviously not. We have a lot more to do. And the first thing that we want to do is we want to make architecture components the default way that people build Android apps. And that doesn't mean that it's going to be required, but it does mean that we want to make sure that as many people as possible get architecture components regardless of how they get into Android development. So that means that not only are we going to be building more tools like the navigation editor into Android Studio that are sort of architecture components aware, but we'll also be adding more templates that include things like view models so that people starting a new project have the easiest possible kind of on-ramp into Android development. And in terms of libraries, not only are we going to be building more architecture components, and not only are we going to be building in more of the kind of core architecture components, goodness like lifecycle awareness into Jetpack, but we want to look at other Google APIs as well and see how we can make those sort of architecture components aware so that, for example, if you're calling another Google API that's asynchronous, right, it already has that built in so that you're kind of getting architecture components benefits whether you know you're using it or not. And then finally, we've heard from everybody that you want us to speak with a single voice. You want us to give clear and consistent guidance. So that means that in terms of education, And that means not just documentation, but it also means sample apps, code labs, that all this stuff is going to be refactored to kind of be built on top of architecture components. So that whether you start with the guide app architecture, or you just download a sample media player app and just start customizing it, that you kind of, regardless of what your on-ramp into Android development is, that we get you to the best possible place. We know that we still have some areas left to address in the core, and you can see some of those here. So this is just to say that we are definitely not going to stop investing in the original set of architecture components. And there's some, not just problem solving here, but some exciting stuff that we can do around how can we make architecture components as idiomatic and fun to use as possible for people using Kotlin. So there's a lot to be done still in sort of, I think, the core set of app architecture and lifecycle problem areas. So we'll keep working there. But beyond that, I think you'll see something interesting about our trajectory if we look at all the components we've launched to date. So last year, kind of this set of architecture components was, these are relatively small pieces, relatively small APIs that are designed to be used in a lot of different places in your app. And then if you look at Room, Navigation, and Work Manager, these are much larger and richer APIs, but they're still relatively sort of self-contained, right? They solve a single problem, and they do it really well. Paging also solves a single problem and solves it well. But in this case, we took a very specific use case, right? So lazy loading for Recycler View. And we're actually, in this case, orchestrating multiple architecture components and pieces of Jetpack to solve that problem. So paging is a little bit higher level. It's not just sort of, here's your object mapping layer, right? It actually takes a very specific, I know I have a Recycler View with more data that I can fit in memory, and uses multiple pieces of architecture components to make that as easy as possible. And we want to continue to build more stuff like that. So we're not just going to keep investing in the core areas of app architecture and lifecycle, but we want to start solving higher level problems and make more and more as easy as possible. But I can't leave today without thanking everybody that helped us get here. The reason that we were able to have a really high quality bar for architecture components was because a lot of people, many of whom are here today, were really generous with their time. And that includes not just filing issues on the issue tracker, but also testing pre-release components, having one-on-one conversations with us to tell us what your biggest problem areas with Android app development were. This has been critical to us in making sure that we're kind of focusing on the right problems and delivering solutions that are going to work for you. So I really have to thank everybody in the community that's been so helpful.
Thank you.
Yeah. And there's a lot more. We had to fly over a lot of content today, but you'll be able to go into a lot more depth in the talks on navigation, work manager, and paging. So thanks a lot, and I hope to see you there.
Thank you.
Hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, because a lot of what she did in the foreground on the characters defined who they were on screen. So that also gave back to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on their feet. That's a whole nother sense of representation and a social aspect for young kids, young girls, and the men who, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You saw the door fight. You saw the king treat them as if they were, when they were the most powerful, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. Very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was, and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. Mm-hmm. And I think technologically, oftentimes, it is the thing for the thing's sake, and not here is, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together. And then pulling from nature. That was a huge one. And thereby keeping everything organic, in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. Mm-hmm. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it, and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, my whole team put every last inch of themselves. So, it was a beautiful thing, because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda, and I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
Challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes, I've read the entire series. Okay. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. Mm-hmm. And our approach to it is going to be, I think, something really cool So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab. And I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All 3 of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, is part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
for it. Oh. Hi, everyone. Thanks for coming today to see our talk. My name is Daniel.
My name is Nikhil.
And I'm Nick.
And today, we're very happy to talk about JavaScript. All right. So if you're in the world of machine learning, if you're doing training a model or any reason, Python has been one of the mainstream languages for scientific computing for the last decade. It has a lot of tools. But it doesn't have to be that way. It doesn't have to end there. Today, we're here to convince you that the browser and JavaScript have a lot to offer to the world of machine learning. And TensorFlow Playground is a great example of that. How many people here have seen this visualization? Quite a few. I'm glad. For those of you that haven't seen it, TensorFlow Playground is in-browser neural network visualization, shows you what is happening inside the neural network as the network is training. And when we released this was kind of a fun, small project. When we released this, it had a tremendous success, especially in the educational domain. And even today, we're getting emails from high schools and universities around the world thanking us for building this. And they're using it to teach students, beginners, about machine learning. When we saw the success of TensorFlow Playground, we started wondering, why is it so successful? And we think the browser and JavaScript have a lot to do with it. For one thing that's very special about the browser, it has no drivers and no installations. You can share your app with anyone, and all they have to do is click on a link and see your application. Another important thing about the browser is highly interactive. In the Playground app, we have all these controls, drop-down controls that you can change and quickly run different experiments. Another nice thing about the browser, it runs on laptops, it runs on mobile devices. And these devices have sensors, like the microphone and the camera and the accelerometer, and they're all behind standardized web APIs that you can easily access in your web app. We didn't take advantage of this in the Playground, but we'll show you some demos later. And most importantly, when you're building web apps, these apps run client-side, which makes it easy to have the data stay on the client and never have to send it back to a server. You can do processing on device, and this is important for privacy. Now, to come back to the Playground example, the library that powers this visualization is not TensorFlow. It is a small neural network library, 300 lines of JavaScript code. We wrote for this visualization, and it wasn't meant to be reusable or to scale for bigger neural networks. But it became clear to us when this became so successful and popular that we should go on and build such a library. And we went and built DeepLearn.js. We released it August 2017. We figured out a way how to make it fast and scale by utilizing the GPU of laptops and cell phones through WebGL. For those of you that are not familiar, WebGL is a technology originally meant for rendering 3D graphics. And the library that we built allows for both inference and training entirely in the browser. When we released DeepLearn.js, we had an incredible momentum. The community went instantly with it and took pre-trained models from Python and ported it in the browser. One example I want to show you of that is the style transfer demo. Someone went and took the pre-trained model, and this demo has an image, a source image on the left, an artist on the right, and then it can mash them together. And they made this in a creative, interesting application. Another demo is people would take models that read a lot of text, and then they could generate new sentences. And then they ported it in the browser and explored novel interfaces, how you can explore all the different endings of a sentence. In the educational domain, people took the standard convolutional neural nets and built this fun little game where you can train your own image recognition model just by using the webcam, and this was very popular. And lastly, researchers took another example. They took a font generation model that can generate new fonts. Previously, it was trained on a lot of font styles, and then they built this novel interface in the browser, highly interactive, where you can explore different types of fonts. Now, building on that incredible momentum we had with DeepLearn.js, about a month ago at the TensorFlow Dev Summit, we announced that we're joining the TensorFlow family. And with that, we introduced a new ecosystem of tools and libraries around JavaScript and machine learning called TensorFlow.js. Now, before we dive into the details, I want to go over 3 main use cases of what you can do with TensorFlow.js today. You can write models directly in the browser. We have sets of APIs for that. You can also take pre-trained models that were trained in Python or other languages and then port them for inference in the browser. You can also take these existing pre-trained models and retrain them, do transfer learning right there on device. To give you a schematic view of the library, we have the browser that does all the computation using WebGL. TensorFlow.js has 2 sets of APIs that sit on top of this. A core API, which gives you low-level building blocks, linear algebra operations like multiply and add. And on top of it, we have Layers API, which gives you high-level building blocks and best practices to build neural nets. And on top of that, because there's so many models written in Python today, we offer tools to take an existing model, a Keras model, and a TensorFlow Safe model. These are 2 formats that are very popular server-side. And these tools will automatically convert that model to run in the browser. Now, to give you an example of our core API, I'm going to show you, we're going to go over code that tries to train a model that fits a polynomial curve. And we have to learn the 3 coefficients A, B, and C. Now, this example is pretty simple, but the code walks you through all the steps of how you would train such a model. And these steps generalize across different models. So we import TensorFlow for TensorFlow/TensorFlow.js. For those of you that are not familiar, this is in standard ES6 modern JavaScript import. We have our 3 variables that we're trying to learn, A, B, and C. We mark them as variables, which means that the optimizer, the machinery that runs and trains our neural network, can change these variables for us. We have our function, f of x. Given some data, it will compute the output. This is just a polynomial function, quadratic function. On top of the standard API like tf_add and tf_multiply, we also have a chaining API. Chaining has been very popular in the JavaScript world, so you can call these methods, these mathematical methods on the tensor itself. And this reads better, closer to how we write math. So that's our model. To train it, we need a loss function. And in this case, we are just measuring the distance between the prediction of the model and the label, the ground truth data. We need an optimizer. This is the machinery that can optimize and find those coefficients. We specify a learning rate there. And for some number of epochs passes over our data, we call optimizer.minimize with our loss and our f of x and y's. So that's our model. Now, this is clearly not how everyone writes machine learning models. Input comes as a string, character by character. So 90 plus 10 is the input to this network being fed as a string. And the network has an internal memory where it encodes this information. It has to save it. And then on the other end, the neural network has to output the sum, 1, 0, 0, again, character by character. Layers. The first 2 layers, I'm not going to go into details, but those 2 are building blocks that can take these strings into a memory, into an internal representation. And the last 3 layers take this internal representation and turn it into numbers. And that's our model. To train it, we need, now one thing I want to point out about model.fit, training can take, we don't want to block the main UI thread. We want our app to be responsive. This is why model.fit is an asynchronous call, and we get a callback once it's done with the history object, which has our accuracy as it evolves. A callback once it's done with the history object, which has our accuracy as it evolved over time. Now, I went through examples of how you write these models in the browser. But there is also a lot of models that have already been written in Python. And for that, we have tools that allow you to import them automatically. Before we dive into the details, I want to go through, show you a fun little game that our friends at Google Brand Studio built called Emoji Scavenger Hunt. And this game takes advantage of a pre-trained model of a convolutional neural network that can detect 400 items. And I'm going to walk over to a Pixel phone and open up a browser just to show you that TensorFlow.js can also run in a browser because we're using standard WebGL. And I'm going to ask here Nikhil on my right to help me out here because I'm going to need some help. Now, to give you some little details about the game, it shows you an emoji. And then you have to go with your camera, run around your house, and find the real version item of that emoji before the time runs out. And there is a neural network that has to detect that. All right, shall we start? All right, let me see. We're going to play it here live. All right, we have to find a watch. 20 seconds.
A watch.
All right, that's great. Woo! All right, let me see what's next. All right, we need a shoe. Come on, Nikhil.
Shoe.
Thanks, buddy. Yay.
Right.
Let's see what our next item is. Banana. We have 30 seconds to find a banana.
Does anyone have a banana? Anyone have a banana? Oh, awesome. We got a banana over here.
Thanks, man.
Here we go.
All right.
Awesome.
All right, so our high score is going up. Let's see what our next item is. Beer.
Beer. Daniel, it's 12:30 in the middle of I/O. Let's get back to the talk, man.
All right, man.
All right, so let's talk a little bit about how we actually built that game. Switch back to the slides here. OK, so what we did was we trained a model in Python to predict from images 400 different classes that would be good for an emoji scavenger hunt game. These are things like a banana, a watch, and a shoe. The way we did this was we took a pre-trained model called MobileNet. And now, if you don't know what MobileNet is, it's a state-of-the-art computer vision model that's designed for edge devices. It's designed for mobile phones. So what we did is we took that model and we reused the features that were learned there, and we did a transfer learning task to our 400 class classifier. So then, once we do that, we have an object detector. So this object detector lives entirely in the Python world. So the next step of this process is to actually take that and convert it into a format that we'll be able to ingest in the web, and then we'll skin the game and add sound effects and that kind of thing. So let's talk a little bit about the details of actually going through that process. So in Python, when we're actually checkpointing and training our model, we have to save it to disk. So there's a couple ways you do this. The common way with TensorFlow is to use what's called a saved model. Details are not important for this talk here, but the idea here is that there are files on disk that you need to write. Daniel also mentioned that we support importing from Keras. Now, Keras is a high-level library that lives on top of TensorFlow that gives you a sort of higher-level API to use these things. Details unimportant. There are also files on disk that it uses to checkpoint. All right, so we have a set of files. And now the next step is to actually convert them to a format that we can ingest in a web page. So we have released a tool on pip called TensorFlow.js. Inside of that tool, we have some conversion scripts. All you do is run this script. You point it to those saved files that you had on disk, and you point it to an output directory, and you will get a set of static build artifacts that we'll be able to use on the web. The same flow holds for Keras models. You point to your input H5 file, and out pops a directory of static build artifacts. All right? So you take those static build artifacts, and you host them on your website. This is the same way you would host PNGs or CSS or anything of that sort. All right, so once you do that, we provide some APIs in TensorFlow.js to load those static build artifacts. So it looks something like this. For TensorFlow save model, we load the model up, and we get a model object back. That model object can actually make predictions with TensorFlow.js tensors right in the browser. The same flow holds for Keras models. We point to those static build artifacts, and we have a model that we can make predictions on. OK, so under the covers, there's actually a lot going on. When we convert these files to a format that we can ingest in the web, we actually are pruning nodes off of that graph that aren't needed to make that prediction. This makes the network transfer much smaller and our predictions much faster. We're also taking those weights and sharding and packing them into 4 megabyte chunks. This means that the next time the browser loads that page, your weights will be cached, so it's super snappy. We also support about 90 of the most commonly used TensorFlow ops today, and we're working hard to continue supporting more. And on the Keras side, we support 32 of the most commonly used Keras layers during that importing phase. And we also support training and evaluation of those models, so computing accuracy once you get them in. Of course, you can also make predictions as well. All right, so I want to show you a demo before I bore you anymore. This demo is built by our friends at Creative Lab as a collaboration between them and a few researchers on Google Brain. So I'm going to go back over here to this laptop. OK, so the idea of this model is it takes a 2D image of a human being, and it estimates a set of key points that relate to their skeleton. So things like your wrist point, the centers of your eyes, your shoulders, and that kind of thing. So I'm just going to turn the demo on here. So when I do that, the webcam will turn on, and it's going to start predicting some key points for me. And I'm going to step back here so you can actually see the full thing. And as I move around, you'll see the skeleton change and make some predictions about me. All right, so there's obviously a lot you can do with this. We're really excited to show you a fun little demo. It's very thin. And what's going to happen is when I click this slider, we're going to move to a separate mode where it's going to look for another image on the internet that has a person with the same pose as me. OK? Let's turn that on. Is it going to work here? Of course, it's not working now. OK, well, we have a physical installation of this, which you can go check out. It's at the experiments tent on H. And it's really fun. It's a full screen version of that where you can see another version of you. We have released this model on NPM, so you can go and use this, and you need no machine learning experience to do it. The API lets you point to an image, and out pops an array of key points. It's that easy. So we're really excited to see what you do with that. OK, so there's a lot you can do with just porting the models to the browser for inference. But since the beginning of DeepLearn.js and TensorFlow.js, we've made it a high priority to be able to actually train directly in the browser. This opens up the door for education and interactivity, as well as retraining with data that never leaves the client. So I'm going to actually show you another demo of that back on the laptop over here. OK, Daniel, you want to come help me? Here we go. Cool. OK, so the game is in 3 phases. In phase 1, we're going to actually collect frames from the webcam. And what we're going to do is we're going to use those frames to actually play a game of Pac-Man. OK, so Daniel, why don't you start collecting frames? What he's going to do is he's going to collect frames for up, down, left, and right. And those are going to be associated with the poses, with the 4 controls for the Pac-Man game itself. So as he's collecting those, we're saving some of the images locally, and we're not actually training the model yet. So once he's done actually collecting those frames, we're going to train the model. And again, this is going to be trained entirely in the browser with no request to a server anywhere. OK, so when we actually train that model, what's going to happen is we're actually going to take a pre-trained MobileNet model that's actually in the page right now, and we're going to do a little retraining phase with data that he's just collected. So why don't you press that train model? Awesome. Our loss value is actually going down. It looks like we've learned something. OK, so the phase 3 of this game is to actually play. So when he presses that button, what's going to happen is we're going to take frames from that webcam, and we're going to make predictions given that model that we just trained. Why don't you press that play button, and we'll see how it goes. So if you look in the bottom right of the screen, you'll actually see the predictions happening. So it's highlighting the control that it thinks it is. And you'll see him actually playing the Pac-Man game now. So obviously, this is just a game. But we're really excited about opportunities for accessibility. You can imagine a Chrome extension that lets you train a model, that lets you scroll the page and click. Now, all of this code is online and available for you to go and fork and build your own applications with. And we're really excited to see what you do with it. All right, man, we got to get back to the talk.
All right.
OK, so let's chat a little bit about performance. What we're looking at here is a benchmark of MobileNet 1.0 running with TensorFlow Python. This is classic TensorFlow, not running with TensorFlow.js. We're thinking about this in the context of a batch size of 1. And the reason that we want to think like that is because we're thinking of an interactive application like Pac-Man, where you can only read one sensor frame at a time, so you can't really batch that data. On the first row, we're looking at TensorFlow running with CUDA on a 1080 GTX. This is a beefy machine, and it's getting about 3 milliseconds per frame. And I want to mention that the smaller the bar, the faster it is. On the second row, we're looking at TensorFlow CPU running with AVX2 instructions on one of these MacBook Pros here. We're getting about 60 milliseconds for a frame there. All right, where does TensorFlow.js fit into this picture? Well, it depends. So running on that 1080 GTX, that beefy machine, we're getting about 11 milliseconds for a frame. On TensorFlow.js running on an integrated graphics card on one of these laptops, we're getting about 100 milliseconds per frame. I just want to point out that 100 milliseconds is actually not so bad. That Pac-Man game was running with this model, and you can really build something interactive with that. The web is only going to get faster and faster. There are a new set of standards like WebGL compute shaders and WebGPU, which gives you much closer to the metal access to the GPU. But the web has its limitations. You live in a sandbox environment, and you can only really get access to the GPU through these APIs. So how do we scale beyond those limitations? With that, I'm going to hand it off to Nick, who's going to talk about how we'll scale.
Thanks, Nikhil. Today, we're launching TensorFlow support for Node.js. Thank you. We're really excited to bring an easy-to-use, high-performance machine learning library to JavaScript developers. The open source community around Node.js and NPM is really awesome. There's incredible movement in the space, a ton of libraries and packages for developers to use today. And now we're bringing ML to this front. The engine that runs Node.js, V8, is super fast. It's had tons of resources put into it by companies like Google. And we've seen the interpreter be up to 10 times as fast as Python. Lots of room for performance improvements. Also, using TensorFlow gives us access to really high-end machine learning hardware like GPU devices and TPUs in the cloud. Look for support for that soon. Let's step back and look at the architecture we highlighted earlier. We have a layers API and then a little bit lower level core API that has our ops. This whole runtime is powered by WebGL in the browser. But today, through NPM, we're shipping a package that gives you TensorFlow, that gives you access to those TPUs, the GPU, and CPU. All of this is through our NPM package. To show you how easy it is to use our node bindings, I wanted to show you a little code snippet. This application function right here is a very common server-side request response handler for an endpoint. Those who have worked with the Express framework know exactly what's going on here. Our endpoint listens for /model and takes input as a request, which we pass into a TensorFlow.js model. and that output is pushed out into the response. Now, to turn on high-performance TensorFlow code, we only need 2 lines of code: an import, which loads our binding, and then an existing API call to set our backend of TensorFlow. Now this model is running with the performance of TensorFlow. What works today out of the box? So we can take pre-existing Python models and run those natively in Node.js. The models we've kind of showed off today, all of those will run in our Node runtime. There's no need to bring a Python stack to your Node infrastructure. Just run it in JavaScript. Our NPM package today ships an off-the-shelf CPU build. There's no additional drivers to do. Just install our package, and you're up and running. Our whole API we ship in TensorFlow.js will work with our Node runtime. Every API we've showcased will work today out of the box. Now, we've built a little demo using Major League Baseball data in Node.js to showcase what you can do with machine learning, Node.js, and JavaScript. We've used Major League Baseball Advanced Media's PitchFX data set to do some machine learning. The PitchFX data set is this large library of sensor data about pitches that baseball players have thrown in actual baseball games. For those that aren't super familiar with baseball, we've given a little context here. A pitcher will throw different types of pitches to fool the player who's trying to hit this ball. There's pitches that have higher velocities. There's pitches that are a little slower but have more movement. In this example, we've sort of highlighted the fastball, the changeup, and the curveball. Those are all types of pitches. Don't get too hung up about the details of baseball. What we're really trying to solve here is a very classic machine learning problem of taking sensor information and drawing a classification to that. So for that, I'm going to actually showcase this demo. All right. So on one side of my screen, I have a terminal, which I'm going to start my Node application with. And on the left, I have a web browser. We've built just a very simple UI that listens to what our server is doing over sockets. Those who have used the Socket.io library in Node know what this interaction is doing. So I'm just going to type Node start my server. And now all through Node, my model is up and running and training. Every time we take a pass through our data set, we report that over the socket to our client. And you can see the blue bar is moving a little bit closer to 100%. That's our model understanding how to tell the difference between a curveball or a fastball. And as you can kind of see, every step, it moves a little bit differently. And our model is having a little bit of trouble at the moment with the fastball sinker, but it's only looked at data for a few passes. The more this server runs, the better it gets at training. So all of this training data we've shown is historical baseball data from 2015 to 2017. I'm going to hit this Test Live button, and this is going to use, with ease, the Node framework to go out to Major League Baseball, pull in some newer data, some live data, and run the evaluation. So once this data comes in, we're going to see the orange bars. And the orange bar shows how much better we are at predicting data that our model has never seen before. These are live pitches, and we're really good at identifying the curveball and not so great at that fastball sinker still. So let's jump back and continue to look at our next slide. This is the architecture of what we were doing in that demo. We've built a very simple Node server that hosts our JavaScript models. And when we hit that live button, it reaches out to Major League Baseball, pulls in that live data, and runs inference on those new pitches. We continuously just report that to any connected clients through the browser. Where does this stack up in performance? So in that training set, we were looking at 7,000 pitches, and we were training every couple seconds 7,000 pitches. So that's an interesting benchmark, but let's actually classify that with the MobileNet benchmark we showcased earlier. So these are the numbers for Python TensorFlow, the GPU and the CPU inference time. So we're just getting started. We've just launched an NPM package. We have a lot of ways to go. but we have some promising early numbers to showcase. TensorFlow with Node.js is exactly as fast as Python TensorFlow. So with that, I'm going to hand it off to Nikhil to wrap up.
Thanks, Nick. Exciting stuff. OK, so let's recap some of the APIs and libraries and tools that we have supported today with TensorFlow.js. We have a low-level API called the Core API, which is a set of accelerated linear algebra kernels and a layer for automatic differentiation. We saw an example of that with the polynomial regression demo. We also have a high-level layers API that encodes machine learning best practices into an API that's much more easy to use. And we saw an example of that with that addition RNN translation demo. We also have showed you a couple ways that you can take pre-trained models from Python via saved model or via Keras models and port those to the browser for inference or doing retraining or computing accuracy. And of course, we also showed you the new Node.js support for TensorFlow.js today. And we're really excited about that. OK, so this project, TensorFlow.js, was not just the three of us on stage here. It was a cross-team collaboration between many amazing people at Google. And we also have some amazing open source contributors that I want to send a shout out to. This project literally would not have been possible without them, so thank you. All of the things that we talked about here today, the demos, all the code is open source on our website, js.tensorflow.org. All of the code is also open sourced on GitHub, github.com/tensorflow/tfjs. We also have a community mailing list. This is a place where people can go and ask questions, post their demos, and that kind of thing. We have some office hours today at 3:30, and we have some office hours tomorrow at 9:30. Which I invite you to come and talk to us in person. And we also have some tents. We have the experiments tent. That's at H. That's where that Move Mirror demo, the full screen version of that will be. And we also will be at the AI tent as well. So we are really excited to build the next chapter of machine learning and JavaScript with you. Thank you.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits.
I can distinctly remember how gaining access to technology can make a difference in your lives. That's why we've been so focused on bringing digital skills to communities around the world. We have trained over 25 million people, and we expect that number to rise over 60 million in the next 5 years. Healthcare is one of the most important fields AI is going to transform. We announced our work on diabetic retinopathy, and we use deep learning to help doctors diagnose it. We can predict the 5-year risk of you having an adverse cardiovascular event, heart attack or strokes. We've been working with our partners using de-identified medical records. It turns out if you go and analyze over 100,000 data points per patient, more than any single doctor could analyze, we can actually quantitatively predict the chance of readmission 24 to 48 hours earlier than traditional methods. It gives doctors more time to act. We are bringing another feature to Gmail, Smart Compose. We use machine learning to start suggesting phrases for you as you type. All you need to do is to hit tab and keep auto-completing. Another product is Google Photos. So we are bringing a new feature. If you took a picture of a document which you want to save for later, we can recognize, convert the document to PDF, and make it much easier for you to use later. Or if you happen to have a very special memory, something in black and white, we can recreate that moment in color and make that moment even more real and special. And we are adding, as of today, 6 new voices to the Google Assistant. John Legend's voice will be coming later this year so that you can get responses like this.
At 10 a.m., you have an event called Google I/O Keynote. Then, at 1 p.m., you have margaritas. Have a wonderful day.
I'm looking forward to 1 p.m.
Today, the Assistant is available on over 500 million devices. Now, by the end of this year, the Assistant will support 30 languages and be available in 80 countries. But one step that we've been working on is something we call Pretty Please.
Hey Google, talk to Voicetron.
Daddy, you forgot to say please. Tell me a story, please.
Thanks for asking so nicely. You're very polite.
I know.
So the Assistant understands and responds to positive conversation with polite reinforcement.
Now, sometimes the Assistant can actually be more helpful by having a lower visual profile. So let's say I'm heading home from work. I have Google Maps showing me the fastest route during rush hour traffic. Hey Google, send Nick my ETA and play some hip-hop.
Okay, letting Nick know you're 20 minutes away and check out this hip-hop music station on YouTube.
Let's say you want to ask Google to make you a haircut appointment. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
That was a real call you just heard. The amazing thing is the Assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. I'm really excited to announce the new Google News.
With the new Google News, we set out to help you do 3 things. First, keep up with the news you care about. Second, understand the full story. And finally, enjoy and support the sources you love. Our AI constantly reads the fire hose of the web for you, the millions of articles, videos, podcasts, and comments being published every minute and assembles the key things you need to know. We're also excited to introduce a new visual format we call newscasts. You are not going to see these in any other news app. Newscasts give me an easy way to get the basics and decide where I want to dive in more deeply. Full coverage is an invitation to learn more. It gives a complete picture of a story in terms of how it's being reported from a variety of sources and in a variety of formats. This is by far the most powerful feature of the app. And here in the newsstand section, it's easy to find and follow the sources I already love and browse and discover new ones. And if there's a publication I want to subscribe to, we make it dead simple. because you're signed in with your Google account, you're set. We're rolling out on Android, iOS, and the web in 127 countries starting today.
Growth of Android over the last 10 years has helped fuel the shift in computing from desktop to mobile. And as Sundar mentioned, AI is going to profoundly change industries. And this brings me to the new version of Android we're working on, Android P. Adaptive Battery uses on-device machine learning to figure out which apps you'll use in the next few hours and which you won't use until later, if at all, today. With Android P, we're going beyond simply predicting the next app to launch to predicting the next action you want to take. We call this feature App Actions. What's happening here is that the actions are being predicted based on my usage patterns. The phone is adapting to me and trying to help me get to my next task more quickly. Slices are a new API for developers to define interactive snippets of their app UI that can be surfaced in different places in the OS. With MLKit, you get on-device APIs to text recognition, face detection, image labeling, and a lot more. And MLKit also supports the ability to tap into Google's cloud-based ML technologies.
Our team has heard so many stories from people who are trying to find the right balance with technology. One of the first things we focused on was helping you understand your habits. Android P will show you a dashboard of how you're spending time on your device. As you saw earlier, you can see how much time you spent in apps, how many times you've unlocked your device today, and how many notifications you've received. Android P lets you set time limits on apps and will nudge you when you're close to your limit that it's time to do something else. If you turn your phone over on the table, it automatically enters Do Not Disturb, so you can focus on being present. No pings, vibrations, or other distractions. You can tell the Google Assistant what time you aim to go to bed, and when that time arrives, it will switch on Do Not Disturb and fade the screen to grayscale, which is far less stimulating for the brain and can help you set the phone down. Well, today, we're announcing Android P Beta.
Maps was built to assist everyone. We've mapped over 220 countries and territories and put hundreds of millions of businesses and places on the map. We're adding a new tab to Maps called For You. It's designed to tell you what you need to know about the neighborhoods you care about, new places that are opening, what's trending now, and personal recommendations. We've created a score called Your Match to help you find more places that you'll love. Your Match uses machine learning to combine what Google knows about hundreds of millions of places with the information that I've added.
Let me paint a familiar picture. Your phone says, head south on Market Street. One problem, you have no idea which way is south. So you look down at the phone, you're looking at that blue dot on the map, and you're starting to walk to see if it's moving in the same direction. Our teams have been working really hard to combine the power of the camera, the computer vision, with Street View and Maps to reimagine walking navigation. So here's how it could look like in Google Maps. Notice that you also see the map, so that way you stay oriented. You can start to see nearby places, so you see what's around you. Now, with smart text selection, you can now connect the words you see with the answers and actions you need. So you can do things like copy and paste from the real world directly into your phone. You're at your friend's place, you check out this trendy-looking lamp, and you want to know things that match that style. And now Lens can help you. You open the camera, and you start to see Lens surface proactively all the information instantly. And it even anchors that information to the things that you see.
Waymo is the only company in the world with a fleet of fully self-driving cars with no one in the driver's seat on public roads. So Phoenix will be the first stop for Waymo's driverless transportation service, which is launching later this year. Soon, everyone will be able to call Waymo using our app, and a fully self-driving car will pull up with no one in the driver's seat to whisk them away to their destination.
Hi, IO Live, it's Todd Kerpelman, and I am here with Asad Naweed, who is a software engineer on ARCore. So, Asad, what's new in the world of augmented reality?
Hi, Todd. So today at I/O, we're announcing 2 new features in ARCore that we're really excited about. We are announcing augmented images and cloud anchors.
Okay, those sound very impressive, but what are they? What's augmented images?
So augmented images is a set of APIs inside ARCore that allow developers to create AR apps that can recognize images in the real world and then anchor virtual content with respect to them. So if your app can recognize an image, let's say this portrait up here, then it can make that image come to life and overlay virtual content on top of that image and make it do interesting things that weren't possible before.
So what kind of apps do you see taking advantage of augmented images?
One other thing that I'm really passionate about is education. And children's education in particular, you could create an app that recognizes the images in a children's storybook. And if kids previously, when they're just reading a storybook, can now point their cell phones at the storybook and then see the story come to life on top of their books, right there and then.
Alrighty, let's check out one of these demos here.
Yeah, so this is augmented images. And we'll see that ARCore finds this image and then makes it come to life like that.
Whoa!
So this is what I was talking about when I meant immersive experiences, is that as we move the phone slightly at an angle, we see that the 3D model actually turns with us. And if we end up going a little closer, we'll see that the effect is much more pronounced. You can actually take a look at the structure of the cubes as they are there, and it's so much more immersive than the standard 2D painting because now you have this box that's reaching into the wall and the image is no longer there, and it's actually been superimposed by this 3D model that's dynamic and can move, and I can get different perspectives on it depending on where I am. So yeah, that's what's really exciting about this.
And is this a phone with any special hardware, any special features? What is this that we're looking at this on?
So this is just a phone that's running ARCore, and ARCore doesn't have any specific hardware requirements short of maybe just like a good camera and a good gyroscope and accelerometer, but that's about it.
All right, and here we have another augmented image. Let's see what's going on here.
Yep, so this is another image that the app knows how to recognize. And now that it's done that, we can see what grows as we move the phone up. And this then grows into like a massive tree that an artist has put together that's rooted at the augmented image. So if we keep going all the way up, you'll see that it becomes like a really, really, really nice tree. And as you bring the phone down, the tree will ultimately sink back into the augmented image that it detected. So these are the kinds of visual experiences and like things that come to life rooted at images that the app knows how to recognize, and that's what we're really excited to see what developers are going to do with.
Wow, that is super cool. I could actually just stay here all day and watch the tree grow and shrink, but I think I have other interviews to do.
No, you're more than welcome to come back when you're done.
All right. Well, if you need me, folks, I'll be hanging out here making augmented reality trees grow. And then the second piece of technology we were talking about were cloud anchors. So what is that, and what does that allow me to do as the developer?
Cloud anchors allow you to create and host anchors, AR anchors, and share them between different people and different devices. And that's really exciting because then suddenly you have the ability to create apps that 2 people can use together to anchor content in the world and see where other people have anchored content in the world as well. One other thing that we're really excited about is that the cloud anchors are actually cross-platform. We're also really excited to announce that anchors created on ARCore devices will also be recreatable on iOS devices running ARCore on iOS. And that opens up the door to so many different possibilities and a significantly larger user base. So now iOS developers can also use ARCore cloud anchors.
All right. So basically, we are setting up a multiplayer game where both devices, an iOS and an Android device, are agreeing on the same augmented reality space that they're sharing. Is that basically what's going on here?
Yes, that's exactly what's going on here, Todd. I have in my hand an iPhone that's running ARCore on iOS, and Brian has an Android device, and we are going to play the same game together. And
all right, let's give this a try here.
That you can see right there is where Brian has placed his board, and I will place mine here. And when I am ready, we are now going to play a game where I have to fire onto Brian's light board. And when I do that, it effectively lights Brian's board up. And then he has to color all of my shots, all of my dots before I manage to do the same thing for him. And he is seeing these boards in the exact same place that I am seeing them in. And I can see him playing the game with me, and the only reason why this shared AR experience is possible is because of the magic of cloud anchors. Woo! So yeah, just to kind of like reiterate, this is an iPhone, it's not an Android device, and we do have ARCore cloud anchors supported on both iOS devices and Android devices, and we're really excited to see what developers are going to do with this.
That is super awesome. I can't wait to play some really fun augmented reality multiplayer games around my living room.
Well, definitely, and yeah, it's a blast for everyone, like the whole family, yeah.
Oh my gosh, that was super cool. If you want to see more exciting videos like this one, head on over to g.co/io/guide for lots more videos featuring me and the rest of the IO Live crew.